Hello everyone and welcome to yet another recreational programming session with Mr. Zozin. So we developing this game in JavaScript, right? So we can even take a look at it. It's called Coil. We only recently came up with the name for this game. It's a multiplayer game. Right now it's in offline mode, but I mean you can actually open this thing in several tabs and you're gonna have several players. So the biggest crime of this game is that it's written entirely in JavaScript. Yeah, like I tried this as an experiment, right, just to see how difficult it is to write something like that in JavaScript. And by the way, it doesn't use any hardware accelerated like 3D stuff, right? It doesn't use WebGL, and neither of the versions, right? It doesn't use WebGPU. It literally renders everything pixel by pixel entirely in JavaScript. It worked out, right? So you can do this kind of stuff and you can make it relatively fast by employing several techniques, but it fucking sucks. It fucking sucks to work with JavaScript. It's a scripting toy language. It's absolutely horrible. If you like this language, like unironically like this language, you just have a Stockholm syndrome. I'm sorry to tell you that. So I was looking for alternatives, right? So, and obviously an alternative would be compiled to WebAssembly, right? So, and recently we found a good alternative for JavaScript for this specific language, and that is C3. So the language is basically markets itself as sort of like a continuation, like evolution of C. It's very much unfinished, right? So I'm not sure if it's alpha or beta, but it's very much like constantly changing and stuff like that. And it has a couple of things that are rough around the edges, but I decided to give it a try anyway, right? So because I kind of like the idea and I kind of like the concepts the developers of the language introduced in there. And I also like the fact that the source code is super simple. It's written in C primarily. It is extremely simple and it's really easy to hack. In fact, in the past, I actually contributed several pull requests to this project. It was actually a very pleasant experience. Thank you so much, Learner, for reviewing and accepting my pull requests. And so, which means that the fact that it's like rough around the edges doesn't really matter that much, because if I encounter some sort of problems, it's very easy for me to just troubleshoot them and potentially fix them. So not only I can use this language for fun, for experiments and stuff like that, but I can also contribute to it, right? So I think it's a pretty good alternative, right? Again, I'm doing all of that because I'm not planning to make any money off of this project, right? I'm just having fun, right? So my entire channel is about recreational programming, right? Programming for your own entertainment, right? So, and that's what it is. So we're going to be using this language. We already explored how this language compiles to WebAssembly, right? So we already know that it does in fact compiles to WebAssembly. There is a pretty cool demo that we developed at some point. So let me find it. I think it was called C3 demo. I'm not sure if it actually sort of vanished or something. I'm pretty sure it was C3. Yeah, there you go, C3 demo. Why did it say it's written in JavaScript? What the fuck? So the C3 is such an experimental language that even GitHub doesn't know about it yet. By the way, I wonder, how do you register a new language for GitHub? Do you file some sort of like a request, and like what do you do exactly? Right, so if I create a new language, how do I let GitHub know that, okay, so there's this language? Does it have to be super like popular or something? There's a file somewhere you can add stuff to. Do you make like a sort of like a pull request to? Oh, I think I roughly like vaguely remember. I think I need to PR. There's, okay, I see. You need to PR somewhere. GitHub linguist. I see. Yeah, they have some sort of like a reusable library for this kind of stuff. GitHub linguist, language savant. I have no idea what they mean by that. If your repository language is being reported incorrectly, send us a pull request. Ooh. Libraries on github.com to detect blob languages. Ignore binary or vendor files, suppress generated files and stuff like that. So that's actually pretty cool. That's actually pretty cool. Yeah, so thank you so much. Maybe we should submit at some point like a highlighting for C3 or something. So this is what we have in here. Right, anyway, so we already managed to develop like a very simple demo very simple demo that uses WASM. And it just like simulates a bunch of physics and stuff like that. The cool thing about this demo is that it works both natively and using WebAssembly, right? So, and this is what we're going to be using to for our game. So the game is actually relatively big, honestly, right? I think it is around 2,000 lines of code as of right now, if I'm not mistaken. Let me actually see. So if we grab all of the MTS files, right? So let me see, MTS, right? And then I just like, you know, count how many lines. Yeah. So it's 2,261 lines of code. So rewriting everything in C3 in one go is kind of like a huge undertaking. So we need to come up with some sort of like at least like a rough roadmap how we're going to be approaching that. So we're going to be approaching that incrementally. We're going to start rewriting things, you know, chunk by chunk, right? So let's actually take a look at the architecture of the thing, right, of the game. The architecture of the game is actually super simple, believe it or not. So it consists of common module, right? So common, how do I spell? Just a second. Common, right? So this is a common module. There is a client module, and there is a server module, server. So web server and application server. That's what we have in here. Who knows the difference between the web server and application server? Who knows the difference? I don't actually remember, actually. I need to rewatch that video. So yeah, anyway. So the thing about the client module is that it runs in a browser, right? So this is in a browser. And this one runs on a server, obviously, right? So the thing about the common part is that it's the part of the logic that runs both in the browser and on the server, and it's usually related to the game simulation, right? To the world simulation, because like it's super convenient actually. If you change how like the rules of the game, they're changed simultaneously on both client and server. Right, and this is one of the reasons like why we need to use WebAssembly, right? So because we need to have this common module that is reused by client and server, right? If we use two different languages, both on client and server, we'll have to implement the same thing twice in two different languages, which increases the surface area of possible errors so fucking much. You really don't want to go into that, honestly. You really don't want to go into that. And this is, by the way, why JavaScript for a longest time was extremely fucking strong in the web, right? Because it's the only language that run in a browser. So if you wanted to create this kind of architecture where you reuse the same sort of logic, you are forced not only to use JavaScript in the client, but also on the server. So yeah, so this kind of situation was pushing JavaScript everywhere, I mean. So since we have WebAssembly, it became a little bit easier, but it's not as perfect as we would like it to be. So yeah, anyway, if I start rewriting like part of the client that uses something from common, that automatically means that I have to start rewriting the server, right? So I have to be extremely freaking careful how I start rewriting things in WebAssembly, right? Because again, if I try to rewrite something in client and it uses common, and I rewrite even a small piece of common in WebAssembly, that automatically affects the server because the server won't be able to use this piece written in different language. So that means I have to start with something that is not in common. And that is probably rendering, right? So you have a little bit of like a chunk of the client that is rendering, right? That puts pixels on the screen, and it usually doesn't use anything from common because the server doesn't really care about the rendering, right? So it doesn't, Like it doesn't even know how the clients see the world. It only manages the state of the world. It only manages the simulation of the world. How you display that, it's kind of like your problem, your client's problem. And because of that, we have this sort of like small isolated island within the client that the server doesn't really know about. And that is a very good place to start rewriting things in WebAssembly. So let's actually go and like take this part and just rewrite it in WebAssembly, and that it like very like easily introduces like a little bit of a WebAssembly into the build process and kickstarts the whole thing, right? And then we can see how we can rewrite the rest of the things and in WebAssembly as well, right? So the cool thing about using C3 is that that means on the server we will be able to use a native version of C3 actually, right? So we're going to have a native application, right? So we're going to have a common module that is compilable both to native and to WebAssembly, right? So, and we know that it's going to work because we literally have a demo that demonstrates that, right? This specific demo, it also works natively. Right, so that's kind of the point. So this is exactly why I implemented it the way I implemented, because I wanted to test that specific sort of like use case. All right, so the renderer of this game is rather large as well. Right, so I'm not sure if we'll be able to rewrite the entire renderer within the stream. Right, so rewriting everything, of course, is a huge task. Smaller task is rewrite only the renderer, and even the renderer is actually kind of a big of a task for a single stream. So we need to actually rewrite maybe some sort of like a small sub part of the renderer on in WebAssembly, right? So some sort of like a small part. So what that small part could be, I think the easiest part to rewrite in WebAssembly as of right now is probably floor and ceiling with the fog, right? Because these things, they are purely just, you know, putting pixels into the image based on the location of the camera. They don't even use any textures or anything like that, right? They only use solid colors, so it's very easy to just implement in C3, right? And then just compile to WebAssembly. And I think this is what we're gonna try to do on today's stream. Pretty reasonable task, I think. I think it's a pretty reasonable task. So, sounds good? Sounds Gucci? Sounds what? Tamaguchi, let's fucking go, my friend. So let's actually acknowledge some subs. So who subscribed? Thank you so much, Element0216 for tier 1 with the message hi. Made yourself 777. Thank you so much for tier 1 with the message next month's Zozi Tsodingasm. Next month's Zozi indeed. Thank you so much, Akoya here with the message hey Zozi, Raylib released YouTube video on some Raylib project but no eepers. It is what it is, and it isn't what it is, and I guess Raysound just hates me. So I don't think so. I'm joking, by the way. Liperium, thank you so much for Twitch Prime. Thank you. As far as I know, from the description, they showcase the thing that people posted in their Discord. Well, Eeper was also posted in Discord. I think Raysound is trying to avoid me, right? Right, so he's trying to avoid me, which is understandable. I'm a very special person. I'm a very kind of special person, so I'm okay with people not trying to associate with me. That's totally fine. I understand that. So anyway, let's go ahead and just start all of this entire shit. So how are we going to be doing all of that? Let's take a look at the client MTS, and we have a function that is responsible for rendering floor and ceiling. Just a second, I'm still a little bit sick. All right. So the function is render floor and ceiling. Yeah. So what it does, it just accepts the buffer image data into which it's rendering everything, and the camera. And the camera is actually very simple. It's just a position, then direction as an angle, and we have a bunch of like auxiliary stuff that is used for FOV and everything. And what we need to do, we just need to grab this entire logic, right? Grab this entire logic and basically translate it to C3. That's what we need to do. So what's cool here is that we're actively using vectors, right? So, and C3 has a native support for vectors, right? It has a native support for vectors. So I think rewriting this code in C3 will dramatically improve it, I think. Right. So because again, we didn't have to use all of these like weird chained methods or anything like that. C3 has a native support for vectors, so that means it has infix operations like plus, minus, and stuff like that for vectors, for 2D vectors. So this entire stuff, these formulas are gonna actually improve in readability, hopefully. We'll see how it goes. So how I'm gonna like approach this entire thing? I'm thinking I'm gonna actually start with a native application that renders a single frame and spits out like a PNG file or something. Right. So let's just like implement this algorithm in a native thing. Right. So isolated from everything else. Right. And once we have that, we can try to compile it to WebAssembly and continuously call within the JavaScript code. Right. So within the JavaScript code. All right. So, yes, so how are we going to be approaching all of that? So maybe I'm going to create something like a floor and ceiling C3. All right, so let's create a separate project for this entire stuff. So, and let's create a hello world. All right, so let's start with something simple. I don't know why this extension actually indents things like that. So stdio. And this is going to be print and I'm going to say hello world. So let's do C3 compile main C3. Is it working? Yeah, it compiled. So we can actually compile run this entire thing. And as you can see, it in fact says hello world. So let's try to maybe, can we use like STB image or something? C3 has a very interesting mechanism of vendoring or something like that. I don't know if it has STB image or anything, but I'm not sure if I want to even use all of that stuff, right? So you see there's external C3 vendor things, and they integrate with the C3 vendor command, right? I never used any of that stuff, by the way, so I'm not really sure. So it's a vendor help, right? So there is this command. Oh, it's not even that. So what was the command? Vendor fetch. Yeah, so it's called vendor fetch, and it fetches things from GitHub, if I'm not mistaken. So the libraries that it has is Raylib. So apparently it has Raylib. So I didn't even have to create my own bindings. So it comes with its own bindings, actually. So does it have anything like a STB image or anything like that? I don't see it actually. I don't really see it, but I mean Raylib comes with its with STB image, right? So maybe this is something that we could use in here. That's actually a pretty cool idea. So yeah, we can just use Raylib for its ability to save images. If it does have an ability to save images, I don't really fucking remember. So let me take a look at the source code of Raylib, specifically at the, you know, at this stuff, like save image. So there is a load image. So what's the, oh, it's called export image, right? So this is what we have. We could try to use something like this. Okay, so if I try to do something like C3 vendor fetch, and if I do Raylib, right, so it's fetching Raylib. For how long is it going to be fetching it? I don't really know. Okay, so it fetched it, and okay, so there is a C3L, and what is C3L? Ooh. So it has this format of libraries, which is basically a zip file. I didn't know that, right? So which is basically zip file. It has the archives, right? Static libraries, has a JSON manifest, right? And so it has also interface file. So, and how do you even use that? Do you just like, okay, so I want to like compile main C3, and then I want to link it with the lib C3L. Files must be non-empty. So yeah, I don't really know. It doesn't allow me to just like, you know, compile this thing like this. It just doesn't allow me to do that. Ooh. So target is using deprecated parameter. So it just saw. All right, it is trying to do some things with that. This is very bizarre, honestly. What if I do import reylib? So it's going to automatically try. No module named reylib could be found. Did you type it right? Yes, I did, if I'm not mistaken. So maybe I need to, you know, specify where it is searched, but I forgot how you specify the path to search for the modules. I used such flag in C3 demo, if I'm not mistaken. Right, I used such flag. No, I don't think so. Like in this specific case, I was just specifying C3 directly. A brief expectation that C3 system, I couldn't figure out how to use C3L. That explains it. Actually, that unironically explains it. I see. Very fascinating. So, but I'm like not really keen to use their build system, honestly. Right, so I prefer like a very simple things. So because of that, I think we're gonna actually approach that slightly differently. Right, so I'm gonna just download the STB libraries, right? So STB image write, and we'll see how it goes. Right, it's kind of interesting, but it's just like not my cup of tea, honestly. Not my cup of tea. Cup of tea. So it's kind of interesting. How do you even use header-only libraries, you know, with a completely different language, right? Because they're kind of designed to be included in the C code, but we don't have a C code in here. So the way you do that, you actually precompile them. Right, so essentially what you do, you just use the compiler. Let's use Clang in this specific case. Right, I'm gonna say, okay, compile it as a module, stb image write.h. Right, so -c means that basically compile it as an object file. And it's not going to work because it sees that it's a header, so it tries to turn it into a precompiled header, which is not what we want. Which is definitely not what we want. So we have to explicitly say through -x what kind of language it is, right? So it is C. So through -x we basically say, okay, compile it as a C file, not as a H file. I think I saw John actually literally renaming it to just C instead. I think I remember him doing that. So let me see. So if I take a look at the GI, right, so and if I try to find a file with a name that has stb image, right, so stb, oh, he even called it cpp. Okay, so that's actually really funny. So he really renamed this entire thing. So he even split it into header. Okay, so that's one way you can do that, right? So that's one way you could do that. But I kind of personally prefer to just use that. Right, so we'll just use a header, right? So I'm just do clang xc, interpret it as a C, compile it as just an object file, right? So, and if you try to compile it, it creates an O file, but it creates the O file that is very small, 672 bytes. So it's empty, basically. So this is basically the meta information of L file or anything. So this is because header by itself doesn't include any what is called implementations, right? So to enable implementation, you have to enable the stb image write implementation macro, right? So essentially what you have to do now is to just enable that, and that should create a big file, which is a 46 kilobytes, and you can link that file with your main application, right? So now I can just do something like C3 compile stb image O. I hope I will be able to do that. So file names must be a non-empty, followed by That's kind of bizarre. So do I have to, I think I have to do -L. Right. Oh, wait a second. Wait a freaking second. Right, so we also have to do M. Right, so it says I have to do M. So how do I link? It was saying something about LM. Could not find. Yeah. So because I have to. That's bizarre. Why can't I just do O files? Why can't I just do O files? So by the way, so let's try to vendor. Oh. I keep forgetting about this thing. Okay, so let me quickly remove all of that stuff. It still fucking gets me every fucking time, right? So this explosion of just like O files, just like oh. So it really gets me every fucking time. So if I try to do C3 vendor fetch. Right. And by the way, so the reason why I'm having troubles right now is because I'm using C3 in a very unconventional way. You're not supposed to use it like that, but I do that because I don't like the conventional way of using C3. I just don't like it. I don't like the build system. I just don't like any of that stuff. I'm sorry. I'm that kind of person. So yeah. So if you use it conventional way, I think it's going to be easier to, like, you're not going to have this kind of problems. But I'm exploring, right? I'm exploring things. I'm just trying to see how they work and how I can make things simpler in a sense of less moving parts. People really like to confuse difficulty and complexity. Here I'm talking about complexity in terms of amount of moving parts, right? So when I say I'm trying to make things simpler, I don't mean that it has to be easy for literal newbies. I'm just saying that it has to be simpler in terms of complexity, so the system has to have less moving parts. That's what I mean, and that implies knowing how things work under the hood, right? So that's what I mean. So because people like to look at what I'm doing and say, oh, hypocrisy, this is not easy. I'm not fucking talking about difficulty. I'm talking about complexity. Okay? Calm down. Anyways, so people really fucking love to confuse these two things. Simple versus easy. It's actually more like simple versus easy for noobs. The current tech industry doesn't try to make things simple. It tries to make it easy for noobs, right? Which actually doesn't mean that the things are going to be simpler in terms of complexity. So anyway, since you have to link with the L flag, right? So maybe you're supposed to actually use this kind of stuff like this. Yes, I think that's how it's supposed to be done. There's no such library. Why it's missing the search path? That's kind of beyond me. Like, why are you saying that it doesn't exist? So do we have to provide the search path? I don't see here if I provided any search paths. Right. So in this specific example, as you can see, I didn't provide any search path. If I try to build the whole thing, is it going to work? It seems to be working, right? So, but when I'm trying to do this kind of thing, right, so it doesn't work, right? So that means I can't really do that. And right, so if I do clang, so this is going to be O file, and if I want to link with the O file, it has to be image O, right, so it doesn't work because it can't find the O file. Oh boy, okay, so let's take a look at the help. Right, so let's take a look at the help. Maybe we want to take a look at the help of the compile command, right? So maybe this is something that I want to pass to linker. Obj output, so link linker option. We can try to do the linker option. Yeah, so there is a flag -z send argument as a parameter to a linker. That is understandable. Okay, so if I try to do something like this, it worked. Okay, so you need to pass the all file to a linker. Right, so you need to pass it to a linker. Not particularly convenient, but I suppose you're just not supposed to use the compiler like this. Right, so you're supposed to use their build system, but I don't like their build system. Right. So let's actually create a makefile, right? And then in a makefile, we can create all of the targets that we actually been, you know, working with. So where's the clank? Right, so I'm gonna put this stuff in here. So then we're gonna create main, which depends on main C3, and it depends on this thing. And this is how we compiling the whole thing like so. So now I can just do something like this, and as you can see, it just creates the application, right? So it simply creates an application. Cool. So now I need to define an external file. How can I define an external file? So stb image write. So we're looking for stbi write png. So as of right now, I only care about this one, right? So this is what I need. So this is basically a function. So here we accept, we don't even have to change anything in here, honestly. We just need to remove the consts, and that's about it. So we can say that it's an external function with this specific name, and that's about it. All right, so I can now try to rebuild the whole thing, and it doesn't really like what is going on in here. So expected function body. So let's take a look at how we do that in C3 demo. So I really like this C3 demo that I've made because it's a good source of examples. I was actually experimenting with doing like a knob style builds for this thing. It kind of worked out, but the subprocess kind of sucks, honestly. Right, so what do we have in here? Oh, we have to put extern in front of fn. Okay, so that explains it. So we have to do extern. Right, so let's try to recompile this entire thing, and it's working. It is working. So let's create some sort of like pixels. Right, so let's just say that we're going to have, we can say something like width 800 and also 600. Right, so we're gonna have width and height. Width and height. So in this thing is going to be just width multiplied by height. And so in here, we can effectively just iterate a single pixel out of pixels. I think if you want to actually reference them by pointers, so this is what you usually do. So I want to fill each individual pixel with maybe a red color, right? So it's going to be something like FF0000FF. I hope hex literals work. I do hope that they do work. And in here, what we're going to do, we're going to just create output PNG. So this is width, this is height. The amount of components is going to be 4. This is the pixels. I suppose we have to take a pointer. Stride in bytes is basically width multiplied by 4. Right, so it's basically width, but in bytes instead of pixels. Each pixel is 4 bytes. That's why width multiplied by 4. Okay, so now if I try to compile this entire thing, does it even compile? Right, it doesn't. Type have to be specified. Okay, so I suppose this is what we have to do in here. Yeah. You cannot convert integer smaller than a point size to... Okay, really? What? What's the... You can't convert an integer smaller than a pointer size to a pointer. But it's not like I want to convert it to a pointer because I'm afraid that it's too big. I'm converting it to a pointer because I want to reference it. I want to be able to modify it like that. So that doesn't make any freaking sense to me, honestly. Right, because as far as I know, I'm not really setting this value in here. Right, but we can try to run this entire thing. So let's actually do IO print n. So here we can say string. Ooh, this one is funny. If I so z string. So because string is actually a slice, it's not a z string. So you have to be really careful about this kind of stuff. Anyway, so I think I'm going to do that a little bit later. So generated output PNG. So I just wanted to extract the name of the file, right, to a separate variable so I don't have to duplicate its name. Right, but as of right now, I'm not really sure how exactly to do that, because here we accept z string, right, so which is a null terminated string, right, so but strings in C3 are kind of different. But that's totally fine, doesn't really matter. Okay. So let's actually try to run this entire thing. Generated output PNG, and as you can see, there is nothing. Right, so we don't see anything. We can take a look at the size of the image, and it's actually 800 by 600, exactly as we expected, but there is nothing because this kind of thing didn't set anything actually. Right, it didn't set anything. Actually, I was trying to reference it as a pointer. Okay, so what if I put like a star in front of it? Is it going to do anything? I didn't think so. Right, it's kind of bizarre. Right, I want to be able to use for each to just modify things, but I mean, it's not that big of a deal. You can always do something like this, right? So where you just do width, or you can do something like pixels len, right? So it's a full thing in here, and in here we just do something like this. But honestly, we still can use for each, right? So you still can use for each if you think about it. But anyway, so let's actually do that. I wonder if I can do the following thing. I can do output PNG. It depends on main, and we just called main, right? So now if I do something like that, right, as you can see, it does the whole chain of things, right? So first it pre-compiles the STB image right, then it compiles the main, then it runs main, and so on and so forth. Right, so that's basically what's going on here. So as far as I know, you can actually, these days at least, right, so you can just do compile run, right, it will compile it and run simultaneously. Right, so and in here it should be red, and as you can see, it's red. So yeah, but I really like to use for each for this kind of stuff, because I think it's too much of a code for just iterating things, honestly. I think it's too much of a code, but I feel like you still can use for each if you want to, right? Because what you can do, essentially, you can iterate pixel, but also I. So, and that's equivalent actually. That is equivalent, almost. And I wonder if I can say, for example, okay, I don't care about I. No, I can't do that, so I have to actually care about this kind of thing. All right, so that's a fair way to do that. I think that's a fair way to do that. So now, as you can see, we can generate like you know, images and stuff like that. That's pretty cool. I see. Okay, is it going to work? All right, thank you so much. Okay, so that's what I wanted. All right. So I'm just confused. I'm just a little bit confused. And to look cool, let's actually make it like one line. Look at that code. Look at that code. This doesn't look cool. I think it looks fucking cool. So fucking cool, mate. Fucking cool, mate. Concise. Cock size. Okay. So what do we have here? So what do we have here? We probably should start, you know, translating the code, right? So we should start translating the code. Let's go to client.mts and let's just grab this function, right? Let's simply grab this function. So obviously it's gonna be fn. It's not gonna return anything. Excuse me. So image data. So this is basically, yeah, so it's a global thing, right? So we're going to be rendering into the pixels. Let's not accept anything. So camera, we probably want to define camera somewhere here, right? So this is going to be camera. And so what's the definition of camera? So I think it's an interface. Yeah, there we go. So it's an interface. Let's put it in here, right? and it's a position. We need to have vector 2, right? So we definitely need to have a vector 2. In C3 demo, I'm going to be using that C3 demo a lot. Right, so I'm going to put actually the link to the video where we developed that demo in the description, by the way. Right, so let's put it TBD, links to all the relevant streams, right? So, because I think the streams were actually very useful, right? So they provide the context of what we're doing right now. Right, so this is C3, and let's go to the C3 demo. And in here, I think in ArrayLib C3, we have the definition of vector 2. We also have the definition of the color. Look at that. This is actually rather convenient. Wait a freaking second. Wait a freaking second. I think we can use that. So I'm going to super quick comment out all of this shit. Right, so I'm going to just comment out all of this shit. Right, so I'm going to try to compile this entire thing. Is it compilable? Yeah, it seems to be compilable. And for the pixels, I'm going to replace uint with color. Right, so look at that. It's not going to compile right away. Right, so 65. So that means instead of doing that, what I have to do, I have to split it into separate components, like so, and just do it like that. And I think now it will compile. But it's not that different, but now I can actually treat each individual pixel as a vector. That's what I can do. So as a 4D vector, which is rather convenient, and it just works. It seems to be working, right? So if I try to do a full recompilation, and I take a look at the output PNG, it is red. So I don't remember in which order it actually puts the things. So if I try to do something like this, is it going to be, so it's like a little endian, yeah. So since we are now directly modifying the bytes, right, the order is exactly what you expect. So that means this is red, this is green, this is blue, and this is alpha. So that means to make it green, I have to do it like that. All right, so now if I take a look at, yeah, there we go. By the way, can I just like take a moment to thank Sean Barrett for creating and maintaining STB libraries? So isn't that kind of marvelous that like a, you know, high caliber software developer that works at Epic Games, previously at Rat Studio, actually donated his time to develop high quality libraries. And I think it is okay for such person to complain sometimes about crappy open source practices. I think he has a right to do that. Can I just like stop for a moment and say that out loud? And he's not an asshole for doing that. So just wanted to say that. Just wanted to say that. Anyways. Right. Anyways, so what do we have in here? So that seems to be working. That seems to be twerking. So how can we compete with Zik? That's the neat part. You don't. You don't compete with any languages. You just lock in and create cool shit. That's it. You don't need to compete with anybody. Right. All of that is for tribalist language people. We don't care about them. Right. It's funny sometimes to poke fun at them, but at the end of the day, just make cool shit. That's it. You can make cool shit in any language. So anyways. So what do we have in here? So this is direction. I think it's going to be a float, right? So in this specific case, it's going to be a float. So let's actually do struct. So FOV left. Do we even use FOV left and right in here? We do in fact use FOV left and right in here, but it has to be pre-computed actually. It has to be pre-computed. Jane Takar, thank you so much for the rate. Thank you. Hello Raiders. Hello Raiders. How everyone is doing? So, so what's funny is that, chat, what's funny is that I developed this shit. I created these vectors as sort of intermediate values because I didn't want to create too many instances of vector. Now we are programming in a proper statically typed native language. I don't have to worry about any of this shit. Like, you don't have to fucking worry about that. Right, so all of this code can be actually greatly simplified eventually. So let me see. So we have half of the height. Okay, so I'm gonna replace this with just height, but I'm not sure. So this code kind of assumes that everything is floats. So that means I probably want to do something like this, right? That's what I want to do. That's what I want to do. Right, so maybe I'm gonna comment out these things, and now what I can do. So here I'm copying that in here. So what I'm trying to do in here, I'm trying to take the FOV left and subtract the camera position of this entire stuff, and I'm just trying to take the length of this thing. Right, so that's what I'm doing. So what is FOV left and FOV right? So I think we need to establish the terms. Right, so let me see. So this is the position. Right, so this is the cone of FOV. This is FOV left. Right, so FOV left. And this is FOV right. FOV right. So that's what we're doing. And essentially in this first formula, we're just computing the length of this specific vector, I guess. I don't remember what this code is doing, by the way, so I'm kind of like relearning it again. And I think this is kind of important because this is like, this length is equal to this one, so we're kind of simultaneously computing for both of them. Right, so, but I'm not sure if this is going to work though. So I can try to compile the whole thing, but it's not going to compile. I know that for a fact. Right, so because, yeah, so this has to be just a float like this, and this is going to be a float as well. All right, so yeah, we are trying to use this code. I'm just curious if this is going to work. All right, what if I comment out this code? Right, and you're going to claim that this code is not properly converted yet. Maybe I'm going to create some sort of a cursor. Right, so something like this, right? So, and it indicates the code that is already converted to C3, right? So everything above this cursor is already converted to C3. Everything below is still in JavaScript, and we're currently working on converting it to C3. So I just want to comment it out and see if this entire thing compiles. Okay, so vectors just have a length method. They just fucking have length method, like by default. And I'm not mistaken, right? So if I try to create it, yeah, okay, so they literally have length. But what is length equal to? Is it length? Подожди, ёба. Wait. So let me see. If I try to, for example, create a vector 2, right, and I say that it's a 1, let's just print it. So IO print n p length, because I'm afraid that it may actually return you the amount of components. Right, so that's what I'm afraid of, honestly. No, it's okay. So yeah, so the length of the vector 1 is actually square root of 2. Oh, okay. All right. You see me my pinor. So I think, the amount of components is probably actually just len, right? So just like with arrays and stuff. Yeah. So it's just nice language, by the way. Nice language. So the length gives you the Euclidean length of the vector, but len gives you the amount of components, right? So not this in this language is just kind of funny, right? So Len is not equal length, exactly. Len is not equal length. Anyway. All right, so that means you can just do that. So I need to uncomment this thing. So here, what we're doing, right, we're iterating rows, right? We're iterating rows, but we're iterating them right to the middle of the whole thing, right? So that's what we do. What's funny is that height, like usually resolution is divisible by 2 always. So I don't really need to keep it as float. I can just keep it as an integer, right? So, and those don't introduce any precision problems or anything like that. So, and then here, now I can use int. Man, I'm so fucking glad. Like all of this stuff, it wants to use integer arithmetics. But I can't use proper integer arithmetics in JavaScript because it's a freaking toy scripting language, right? So where all of the numbers are fucking floats. Finally I'm programming in a proper language. Thank you, God. Oh my god. So I don't have to deal with any of this shit. Right, so I'm starting from the half, right? So, and I'm just like going forward. Okay, so if I try to compile this entire thing, right, so image data, so this is height, we have to replace this entire thing with height. So, and the code becomes simpler, look at that. Alrighty, so what do we have in here? So we're taking the height and then we're subtracting the current y and -1. So essentially we are iterating floor and the ceiling simultaneously, right? So this is what we're doing, and this is SZ is sort of like an opposite, opposite thing. So if Y is basically floor, since it goes from the middle of the screen down, so that means it's a floor. So we find the opposite thing, and SZ points at the row of the ceiling. That's what we're doing in here, effectively, if I understand correctly, right? So, and this could be integer, by the way, right? So all of these things are integers, so we are iterating integers. So BP is float, which is understandable, right? So it wants to be float. Okay, so let's actually compile. So we have a lot of subs. I probably need to acknowledge them. Just a freaking second, my friend, just a freaking second. Liberium, thank you so much. Wrench, thank you so much for tier 1. Sectox, thank you so much for tier 1. Corunner, thank you so much for tier 1 with the message 3C. Thank you so much. Branch Wag, thank you for the gifted subs. John D. Resta, thank you so much with the message. I'm starting to see ads. That means it's subscription time. Alright. That's how they debate you to pay you money. Ira SW, thank you so much for Twitch Prime. Alright. So that seems to be working. Okay, so here we're computing the difference between the middle, right? So PZ, as you can see, is the middle of the screen, and SZ is the sort of the opposite thing, right? So, and I suppose it also has to be an integer. Okay, so afterwards, what we're doing, we're dividing the length of this FOV vector, right? FOV vector by AP, which is the distance. Yeah, I see. So we're just doing a little bit of trigonometry, right? We're just doing a little bit of trigonometry. And we need to know the near clipping plane, right? So which is a constant. So that means we need to go to the client MTC and stuff like that. So actually, let's bring all of them in here. Right, so we're going to have some constants in here, so which are going to be, I suppose, floats, right? So since the near clipping plane is 0, 1, right? So all of these things have to be floats, I think. So BP is float, so AP is the integer, so this entire thing is going to be float at some point. I wonder if C3 actually automatically converts integers to floats in these specific situations, or you have to force cast them. So I wouldn't mind if it forces you to cast all of that stuff. So by the way, if you don't understand what the fuck this code does, don't even fucking worry about that. I don't understand it either. It doesn't matter right now. What matters is that we need to translate that code to C3. So that's it. So don't even fucking worry about that. So it was complaining about something. I don't freaking know what it's complaining about. So 32, accidentally actually did an oopsie doopsie and fucky wucky. Right, so we're just translating the code, nothing particularly special. Oh, right, okay, so you have to convert this kind of stuff to floats, right? So AP has to be a float, PZ has to be a float. Okay, understandable, let's go. Anything else? Oh, and this thing has to be... Oh, it was probably talking about that thing. All right, so can I do it now? Yeah, boy! You don't even have to do that. So it automatically moves integers to floats, right, when it's needed. Okay, so that's understandable. That's actually understandable. Okay, so now, look, we have this very huge expression, and I think now we can simplify it greatly. I'm pretty sure we can simplify it greatly, because what we need to do in here, we just need to grab the FOV left, subtract the camera position. Right, so subtracting the camera position. We need to normalize this entire thing. I don't know if normalizing is gonna actually work. Then if we want to scale it, we'll multiply it by B, and we add the camera position back. So, and then we basically assign all of that to T1. Just a second. So yeah, that's what we need to do. I'm not sure if normalization is going to work. So let me see. So normalize doesn't work. What if I do normalize? Right, because it has length. So that means it probably has like a common operations and stuff like that. So let me see. It fucking has normalize, okay? So essentially, we managed to convert this kind of expression to this one. Isn't it cool? I think it's pretty cool, actually. Really fucking like that. Yeah, so let's actually grab this one and let's try to convert that. So we take FOV right, subtract the camera position, we normalize, and then we scale by B, and then we just add camera position back. So vector 2 T2. So that's basically what it is. Yeah. So that's about it. So we normalize it, then we rescale it, and then we add the camera position back. So that's basically what's going on here. All right. So then next come the comments, right? So I think I can just keep it like this, nothing particularly special. All right. So and afterwards, right? So here, as you can see, we're iterating the rows. And then, once we figure out what we need to put into the row, we start iterating columns, right? So here, as you can see, we're iterating columns. So, and in here, I suppose I need to do something like this. And yeah, there we go. So it's going to be integer x. So this is width. Yep. And now we just need to convert all of that. So in here, yeah, we try to get the color of the floor and the ceiling. So we'll need to translate these functions to C3 as well. Right, so let's try to recompile this, since I think it's recompiling, so that's pretty cool. Now, if I go, so we have T, so we take T1. Oh, we're trying to lerp between them. Damn. So how can I easily lerp between two vectors? I can always do something like T2 minus T1 multiply by this value, right? So just multiply by that, and just add T1 back, right? And that's what we can have in here, and this is what we can assign this stuff to. But maybe there is lerp function in a standard library somewhere in C3. So it's actually C. C3 length, lib C3. So let's rg vim grep lerp. Do okay. Oh. It literally fucking has lerp. So it's a macro that is sort of like a method. So it just does lerp. I don't really fully understand this macro, but apparently... Oh, okay. So, but it's private. I'm not sure if I can just use it. Sure if I can just use it. So I didn't know what private honestly means. I would like to have some maybe examples on how you use .lerp, right? Because I don't fully understand. So it advertises to be sort of like a method. Ah, I see. I think it literally works exactly as it works in JavaScript. Right, I think I can literally do something like t1 lerp t2 like this. Right, and then it's just width. But also, excuse me, I think I have to convert it to float. Alright, so I think I can do that. I'm pretty sure. Huh. Okay, so let's try to compile this entire thing. Damn, and just compile. It just works. Guys, it just fucking works. Can your Zig do that? Joke. Alright, so let's actually grab all of these methods. Scene get floor. Right, so let me see. So scene get floor. And yeah, so let's actually like literally copy paste all of these functions in here, like so. Yeah, so we try to compile them. They're not gonna work. So let's start with this one. So it's gonna be a function. We can return caller, right? So we can just return caller. Right, and in here, we just accept p. So now in here, I can just do px plus p. Well, I mean, I probably do need to do floor, don't I? I'm pretty sure. Right, so can I just do something like floor? So math floor. Okay, so there is a macro. I probably want to import std math. Right, so get floor, and here just do math floor, but maybe there is a method for flooring. Let me see, is there something like floor? Okay, you can actually do it as a method as well. Excuse me. Honestly, methods in C3 are kind of interesting. Yeah, they're kind of interesting actually. Kind of close to Go methods, but also a little bit more advanced, I think. So here we return scene floor 1 and scene floor 2. So that means we need to also grab them from the JavaScript code. I mean the TypeScript code, but I mean the same shit. Same shit. Right. So this is a const. And this is going to be the caller. So the problem here is that we are using normalized values in here, honestly. These are normalized values. We need to convert them to integers. Excuse me. Oh, Mr. Stemmer, you are streaming for more than an hour. Time to make a small break. Yeah, so C3 is so much better than Zig that I just can't stop programming in it. It's just like I forgot that I need to make a break. That's what a actually good language does to you. So yeah, let's make a small break. Right, so I think I'm also starting to lose my voice. So yeah, it's time for a break. All right. So I'm back with my cup of piss. And yeah, we just need to convert this stuff to like a proper callers and stuff like that. So how am I going to be doing all that? I could just try to do that manually, but it's kind of annoying if you know what I mean. If you know what I mean. So we can try to just grab this thing. Right. So in here, I can just multiply it by 255, and in here I also have to multiply it by 255, and this one is also multiplied by 255, right? So, and I just like need to spend some time converting all that. Maybe I can use Python. Maybe I can automate some things with Python. Look at that. Look at that. I can automate some things with Python. Can I just import math? Right, and just like, so do I have floor? Or is it part of the, yeah, so okay, so it's a part of that. Math floor. Math. Honestly, maybe I can do some actually much simpler scheiße, meine Freunde. Can I just map that stuff with floor? Tuple. Okay, so what if I say that this is a list? Object has no... yeah. So you have to do map floor, math floor. Sure. But I mean, after that, I can actually do hex on this entire thing, and then I can convert it to list. Can your Zig do that? I don't fucking think so. 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 You know what I'm... What if I just create something cool, like 2RGB, which RGBA, which accepts a bunch of like components and stuff, and it just like, you know, iterates them like 4x in axis, and in here we simply do math floor. I could have used like list comprehension actually. I don't know why I didn't do that. And just hex. Look at that. On top of that, we can even just multiply them to 155. And now I have 2 RGBA. RGBA, and I can literally just grab this entire stuff, convert it to a list, put it in here, and it didn't do anything, so I suppose I have to print it. I see. So I think I forgot to return this entire stuff. Yeah, that's what I forgot. So now I don't even have to print that. So that's pretty convenient, isn't it? We're automating things with Python. So now what I have to do, I just have to get rid of these things, boom, and just replace that with curly braces, boom. Look at that. Isn't that a poggers, my friend? So this was, that was basically that. Yeah. So that's pretty cool, I think. So that means I can now quite easily grab this stuff, replace it, turn it into a list, to RGBA, like so, boom, another one. And yeah, that is super fucking convenient, mate. Right, so let's remove that, and there we go. So that's pretty cool. Can your Zig do that? Can your Zig do that? So, have you seen Mojo? Yes, of course I've seen it. So people kind of stopped talking about it. Is it still a thing, or is it already dead? So it's kind of funny how the hype around it like died out. Like nobody gives a shit. Nobody gives a scheiße. It was an internet meme. I thought you were talking about the language. You're not talking about language? I thought you were talking about language. Or is that you talking about like Watch Mojo? It's that one. Right. Watch Mojo. So query replace this thing with that. Mojo is infected with AI slop. I mean, it was specifically designed for making AI slop from the get-go. Like, I mean, you can't infect a virus. So, not really sure what exactly you're talking about, right? It's just like, yeah, it is designed for making AI slop. Like, it's a language for AI slop. Look at that, it compiles. Look at that. Okay, so we converted one function to C3. Now we can convert another one. So it's going to be fn cola Right, so, and let's just put it in here. And this one, we can do some cool scheisse, I think. So it's going to be floor. Boom. Yeah. But when we're doing floor, this makes sense to... yeah. Yeah, I think that's about it. Right, so let's do make. And that seems to be working. Cool. So we converted everything we needed in here. So now, as you can see, we take the floor tile, which is going to be just color, right? So does that work? Yep, that compiles. That is actually super cool. But what's funny is that we don't need to check whether it's RGBA or not. In this specific version, it is always RGBA. So that means we always do this, right? We always try to render it. So what we do in here is rather cool, right? So we are computing the index within the pixel array. So we take y and we take the width of the buffer plus x and we multiply it by 4, presumably because we address it by bytes. But now we can address pixels by pixels. So we don't really need to multiply it by 4. So we can just keep it like that. So that's pretty cool. So we also have a little bit of a shadow in here. So I think for now, I'm gonna do, maybe I can just do that. So if I try to use the distance, I haven't checked if it compiles or not. So I think the first thing I need to do, I just need to put int in here. Let's try to see if it compiles. Right, it seems to be compiling. Okay, so that's cool. So now, shadow, we take the camera position and we compute the distance to t. So, well, distance is basically t minus position, right? So multiplied by 255, and well, it has to be length, essentially, right? So it has to be length. So now what we're taking pixels, and we're taking destination p, and we're setting the floor tile to that. But we also want to multiply the shadow. The problem with multiplying the shadow is that, well, this one is rather interesting. So we can actually do, so floor tile x maybe RGB. All right, so we're constructing RGB. And I wonder if you can now construct A out of that. Is that something you can do like this? That's a good question, right? So because as you can see here, I want to multiply on the shadow by RGB. So maybe it will work out, maybe it will not. So let's try to compile and see, you know, compilation errors. Okay, shadow, it has to be float. That is understandable. Yeah. A float cannot be implicitly converted to char3. Understandable, actually. Oof, this one is rather interesting. So what if we, for now, remove the shadow? Right, let's just remove the shadow and do all of that stuff without the shadow. Might as well just do floor tile. There we go. And shadow is more like a fog, actually, for now. So it's more like a fog. So here, it probably makes sense to actually have a separate scope, because specifically in here, as you can see, we're using the same variable, right? So we're using the same variable, so it's better to, you know, isolate them in a separate scope. So this is a ceiling tile, so we can actually do something like this. So this is a floor tile, this is the ceiling tile that we get in here. Right, we don't care about whether it's a color or not, it is always a color. Right, so in here, this is the destination for that specific thing. So let's actually put a separate scope in which we're going to be doing all of that. So we can even put the ceiling tile in that scope. So yeah, so we don't have to do that stuff anymore. This one is just a width. This is integer destination. Shadow, we're gonna keep the shadow as it is right now. And in here, we're gonna just have pixels destination P, it's a ceiling tile, and I can just remove that. So something like this for now. Yeah. And that means we successfully converted the entire function that renders floor, and it turned out much simpler, if you think about it. It is actually much fucking simpler. To be fair, in this specific, it's so goddamn simple that I don't understand why I don't just inline all of that shit, because I can do this kind of stuff and just remove it. And I can also inline this kind of stuff, and I just can remove the rest of the things in here. So the dynamicness and toyness of JavaScript, it just makes everything more complicated, right? When you have like a proper language, like it's so much fucking simpler. It's just like simple arithmetic operations your CPU can do. All right, so you don't have to go through all of these hoops because it's a dynamic language and it's also trying to be newbie friendly and it's also managed and stuff. Like fucking don't. Like, I don't fucking know. Anyway. So you can also inline all of that stuff, and it's just like it makes code like simpler and easier to read. It just fucking does. It just fucking does, brother. Alright, so what do we have in here? What's funny is that you can kind of use the same shadow in here. Right. Man, the fact that you need to write so much code in JavaScript is a fucking crime. I swear to God. Like, what the fuck? Oh boy. Anyway. Clean code, exactly. Exactly. Clean code. Clean coke. Okay, so does it compile? Let's actually see. I think it does compile. We can now try to render this thing. Alright, so instead of filling it up, we're gonna do render floor and ceiling, and we have to provide the camera, right? So how are we going to be providing the camera? So the camera is essentially, yeah, it has a position. I can set the position to maybe 0, right? So something like 0, 0. The direction, we also can set it to 0. It doesn't matter. We need to figure out how to do FOV left and FOV right? So we need some code that computes them. And that code is available within JavaScript code, right? So FOV left equal, or is it, yeah, so update camera. Update camera takes the player and just does all of these computations, and I think this is something that we probably want to port in here. All right. So update camera, so this is going to be void fn. Can I just make it a method? Camera update. And yeah, so position. Let's actually don't do that. All right, so this is a camera, so we'll probably accept it by that. Right. So this is a half of a FOV. How often do I use that? So we use it in quite a few places, so it's going to float. So we need to know FOV now. So we need to take the pi, let's put it in here, so it's going to be float. And where is the code that is responsible? Yeah, there we go. This one has to be here. So we have FOV len. Now, what I need to do, so we set in the position. So let's remove that. So the only thing we need to do in here is set polar. Do we have anything about polar coordinates in math specifically? Polar angle? No. So probably one of the things we want to do in here actually is just like from polar, and in here we're gonna accept angle and length, and the idea in here is that we just do math cosine angle multiplied by len, and this thing is supposed to return vector 2, right? So and math sine angle multiplied by len, and just return this kind of stuff from polar. Okay, so we can do camera, FOV len, from polar. Well, I mean, I could just like directly modify this entire thing. So we are creating from polar, and then we adding the camera position, like so. So that's what these things are. That's what these things are. I suppose cosine here has to be math cosine. And that's about it. Do we need anything else? I don't think so. Let me see. Does it compile? So something about at 90, which is understandable. One of the things we probably want to do, actually, we want to create a camera, like this. We can just create a camera, I suppose, and then we can try to update it, which updates FOV and stuff like that, and then we can pass the camera in here. So math pi. Do we have pi in here? We do. So math pi, it's more like math pi. All right, it compiles. And if we take a look at the output, easy peasy lemon squeezy, easy peasy lemon squeezy. Look at that Scheiße, meine Freunde. Look at that Scheiße, meine Freunde. Look at that Scheiße, meine Freunde. Okay. This one is rather interesting. So, because it's a shadow, but it's also multiplied. So we need to port the shadow. I would like to really port the shadow. Server-side rendering. I mean, it's going to be on the client. Right, so because we're going to eventually compile this entire thing to WebAssembly. Right, so that's what we're going to do eventually. How much time does it take to actually do that? I'm curious. But I mean, that time is going to include, if I just compare the time, it's going to include STBI write PNG. Is there something to compare performance in C3? I wonder. Honestly, to compare the performance, we need to use this kind of stuff. All right, so let's use the same resolution that is used with within the JavaScript game. So we already have width. So width is supposed to be an integer, and it's just a factor. And a factor is 30. So since we're talking about like a proper language, we don't need to floor anything in here. Right. Nothing needs to be floored in here. All right. So what do we have? It's yeah, it has to be a factor. Has to be a factor. Cool. So if we take a look at the final thing in here, yeah, this is the actual resolution of the game to which we're rendering things. All right, so because otherwise it's kind of too slow. And I wonder, do we have any like way to measure performance? Right, so maybe let's grep rg vim grep performance. No, bench. Okay, there's some stuff for benchmarking. What I'm going to be able to do is to just measure some time, I suppose. So we have benchmarking. So there's a clock. Right, so there's a clock. How do we even use the clock? Okay, so we do that. System clock started. Right, so... Okay, so we're basically creating the clock. We then use sys clock started. Sys clock finished. Okay. So that is understandable. I don't really understand what the fuck is this shit. So what is that? Why does it have to be like this? So sys clock. Sysclock. So sysclock. It's a built-in functions. Ah, I see. Not really sure why we have to do this kind of stuff, but I mean, okay. So let's give it a try. I'm gonna go to the main C3 runtime. So what is a C clock? It's a long. Now here we can just try to do something like this. Sys clock. And we can do something. That's bizarre. How bizarre. What the fuck are you doing, my friend? Alright. IO print n so finished minus like this. That's what I want to do. Just want to see how quick it is. And what is that? Is that milliseconds? It's probably not milliseconds. Is that microseconds or nanoseconds? Milliseconds. Well, I mean, that's milliseconds is 1,000, so that means it took. Nah, I don't think so. No, I don't think so. So let me actually see how we use this stuff. So sys clocks. So sys clocks, if I benchmark, it's a nanoseconds. Because it's a freaking nanoseconds. All right. Interesting. So a nanoseconds, that's a lot actually. So this is right, milliseconds. So 1, 2, 3, 1, 2, 3, 1, 2, 3, something like that. So that's what we want to do in here. So conversion to double, explicit conversion to double. Can we just do F? Oh, I mean, okay. Double. Okay, fair enough. Below 16 milliseconds, honestly. Below 16 milliseconds. Still kind of slow, honestly. I would expect it much faster. Yeah, no optimizations. Let's actually enable some optimizations. Okay. That's much better, I think. Yeah, that's much better. Damn, bruv. Optimization go up to 0.5. Jesus. Okay, that's all right. So, how aggressively can you optimize shit? All right. So we've got that. That's actually reasonable. That's pretty good. That's pretty good. Alrighty. But we haven't even introduced any shadows yet. We haven't introduced any shadows. So why do I pre-multiply it with 255? I'm not kind of sure. Yeah, this is probably because we're multiplying it. So let me take a look at the render floor and ceiling. So yeah, I multiply this. I know why. I actually know why, because this thing is normalized. So okay, that makes sense. Sure. So I don't have to multiply it by 255, right? So the only thing I need in here is just the distance. And I don't even normalize it or anything, so just like used as it is. I could simply use it like so, but I'm not sure how convenient that is. Honestly, I'm not sure how convenient that is. So because like it requires conversion between chars and floats and stuff like that, so it's kind of meh. Right, so it's kind of meh. But we need to do that to replicate the image exactly. Yeah, okay, so that's what we have in here. Can I explicitly cast this entire thing to just, you know, float 4? Is that something I can do that will actually work out? So cannot be implicitly, okay, so that's understandable, because we're then trying to assign it back to chars, and this is char 4. That is understandable. So we're just going through the sequence of casts. All right, so that's cool. And if I take a look at this, it kind of works. Okay, so that's fine. So the middle one is kind of weird, but we can just fill up everything with white color and it's gonna be fine. So this is literally how the game looks like, actually. Right, so if you bring the shadow, it's more like a fog, actually. It's not really shadow. Right, so it's a fog. It's a fog, and on top of that, I can basically do for each pixel, pixels, pixel 255 to 55, like so. So if I try to do something like this, we casting now, boys. Yes, look at that. Oh, it didn't fuck. What the fuck is going? Why is it still? Does it still have this shit? It's something overflows in here, in there. I swear to God, something really fucking overflows. And I'm not 100% sure. Something also with alpha. So alpha, maybe it's something with alpha. So how are we gonna be approaching this entire stuff? Because what I want to do in here is maybe take RGB, just multiply only RGB, but that just means this thing has to be 3. But then how do I convert all of that stuff to this stuff? Like, I don't really know how swizzling exactly works in C3, so let me see. Maybe if I was a graphics programmer, I probably could guess, because maybe it's implemented in an intuitive way for graphics programmers, but I'm not. So I don't really use swizzling that often. So let me see some examples. So yeah, that's understandable. That is actually understandable. I don't know. I don't know. Because, yeah, so I just want to do that. So I'm also casting it to that. But afterwards, I kind of want to convert it to 255 and 255, something like this. Well, wait a second, I can actually do that slightly differently. Let's actually take a look at what the compiler will say. Yeah, so you're trying to convert the vectors of different sizes, which is meh. Alright, so if I try to convert the same sizes, it says that you can't assign char 3 to char 4, but then can I say that, okay, so just create an extra vector in here. Is that something I can say in C3 programming language? Are you fucking serious? Is this really something I can say? Hey, apparently I can. So it's pretty cool. Yep. So let me see. Oh, well, at least there's no middle thing in here, but now I kind of understand what's going on here. It's definitely overflowing. It is 100% overflowing. Question is, how can I not oversaturate it? Right, so how can I clamp it? So there should be a way to clamp it. Clamp. And yeah. So clamping, as you can see in here, accepts another vector. So it has to be a vector if you want to clamp it. It has to be a vector. We can try to do that. So this is that. Clamp. Also, if I want to create like a vector from a single component, how can I do that? That's the real question, right? So if I have a single component, what's the easiest way to do that? Vectors. So there is math, sum, swiveling, array-like operations. Oh, yeah. Because what essentially I want to do is just... Yeah, that might be a good idea. All right, that might be a good idea. So 255. So 0, yeah, 0, xxx. Right, so you can use RRR or xxx, right? So it doesn't matter. And then 255, which is also xxx. All right, so that's how we're clumping. We're clumping, boys. Doc says 4. Ah, so that means I can just do that. All right. That's pretty cool. I can't do that. So integer cannot be float. Though, what if I say it's a float? All right, so it's a float now. Aha. How? So do I have to do it like that? You can't cast float to that. Understandable. But now, what if I say xxx? Are you gonna be happy now? Untyped list. Okay. Untyped list. So one of the things we can do, actually, we can do maybe something like float 3 low, right, which is that, and 3 high. And maybe that's what we can do. Low, high. I mean, it's understandable, but I would like to be able to just inline this kind of stuff. I would like to be able to just inline them, but I guess that's fine the way we do that. It's fine the way we do that. All right, so let's take a look at what we have. There we go. Look at that. Look at that, motherfucker. Look at that. Look at that. Look at that. Look at that, motherfucker. Look at that. That's pretty cool. First try, exactly. First try. Purified image. Purified image. So that's actually super cool. I'm really happy with what I see. I'm super happy with what I see. Oh boy, oh boy. Okay, so yeah, now we probably want to try to compile this stuff to WebAssembly and see how it fares in WebAssembly. Time to compile to WASM, exactly, but I'm already streaming for 2 hours, so I'm not sure if I want to really go that much over time. So, yeah. Because, so what it will take to compile to WebAssembly and integrate it into the game, right? So because I want to, in a single episode, right, not only compile to WebAssembly, but also integrate it into the game, so the game actually uses the WebAssembly module. So it feels like another 2 hours, honestly. It does in fact feel like another 2 hours. And I'm currently still sick a little bit, so I don't really want to push myself too much on that. So the idea is going to be the following, right? So we're going to split it into 2 episodes. I'm going to continue this stuff tomorrow. Right, and then on YouTube, I'm gonna upload the concatenated single episode where we go from nothing to this module to being integrated. I'm sorry, It's difficult for me to actually go for a very long time, right? So I'm like a week after the sickness. So yeah, I guess I'm gonna call it a day. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all tomorrow. Tomorrow we're gonna continue. We're gonna compile this entire stuff to WebAssembly, right? And then we're gonna integrate it into the main game. So the main game uses combined renderer, right? So first we're gonna do the first pass by calling the WebAssembly module to generate the walls, and then the second pass is going to generate ceiling and floor, and then the second pass is going to add the rest of the things. And that will actually enable us to incrementally move things from JavaScript into the WebAssembly, right? Incrementally. So we are basically preparing everything for slow incremental rewrite. So that's the plan, basically. All right. Thanks everyone for watching. Love you all. Mwah. All right, this is the next day, and let's actually go ahead and try to compile this entire application to WebAssembly. Oh, by the way, I never actually tried a very interesting thing. So as you can see, now it generates the the camera in this particular position, but we can actually rotate it. So if I set the direction to something else, right? So direction. That's what I want. What the? Emacs, are you okay? All right, so I can actually set the direction. Maybe I can even save this entire thing. And then if I do C3C compile, compile run main C3, right, so it doesn't, oh yeah, so I have a make file, right, so I have a make file. All right, okay, there we go. It's still don't understand why the fuck it does that, but that's what it does. And now, yeah, as you can see, I can actually rotate a little bit, right? So I can control the camera, and I can actually render at different angles and stuff like that. So this is actually kind of cool, I think. This is actually kind of cool. So yeah, well, we need to finally compile this entire thing to WebAssembly. So we have a little bit of a code related to WebAssembly. Like, is it going to keep all these O files in here? Right? Can I just like? I think it actually, like yesterday it sucked them up into the executable. Right? I don't know why it keeps creating them right now. Because usually it creates them when it, okay, so I think maybe it's something from the, from some sort of a previous failure or something like that. Anyway, so in C3, right, in C3, C3 demo specifically, we have some command line things that would be helpful to compile all of that to WebAssembly. So let's actually go ahead and introduce all of that. So what I'm thinking, so we're going to have something like all, which is going to be output PNG, and let's also introduce something that creates a main.wasm. Right, and main.wasm depends also on main C3, and to create main C3, right, is it main? Yeah, it is main. So in here, what we're going to be doing is essentially creating main from main C3. So we have a lot of flags in here, right? And one of the things they do, by the way, they instruct to not link with any of the libraries and to not have any entry points or anything like that. So I think it's not going to work because our current application in its current form does have an entry point, by the way, and it uses standard library, and it also links with the C code. None of that is probably going to be easily compilable to WASM, but that's totally fine as of right now because I want to see the compiler fail. So then I know how to fix all of these things, right? So let's actually go ahead and try to compile this entire thing. So we can try to maybe create main.wasm specifically. And there we go. So no module named IO could be found. Did you type name right? Okay, so basically it cannot actually link with all of that. So interestingly, there is conditional compilation in C3, if I'm not mistaken. So let's actually take a look at some of the stuff within the standard library in here. So I remember there was some sort of like a macro or something like that, like a add if that they would use. Yeah, there you go. So basically you can include or not include a certain entire module, right, upon having some sort of a variable in here. But this is specifically module. I wonder if there's something that, can you like not import certain thing? Right, okay, so you can slap if at the definitions. I'm really freaking curious if you can do that on imports. Right, so is there something like WASM? WASM no libc. Aha, this one is interesting. So there's a WASM no libc. So maybe that's what we can do. But the thing is, we here disabled not only libc, we disabled also a standard library. Maybe one of the things we can try to do in here is, in fact, enable standard library, but do not enable libc. That's a very interesting thing that we can try, actually, chat. Is that an interesting thing we can try? Right, so we're using a standard library, but we're not using libc, and all of that is WebAssembly. I think the last time we tried all of that, it didn't really work, but this is because I was using the the stable release, right? So here I'm actually using the bleeding H. Right, so let's actually go ahead and try this. Assuming non-POSIX environment, okay, and it worked. It probably generated like a huge, well, I mean, it's not really that huge, but I mean, 45 kilobyte. Why did it fucking work? I think I know why. Wait, damn, bruv. So we have some external shit. It probably now expects this external shit from JavaScript. I swear to God. So now we should... It probably all means that what we have to do now is basically provide our own implementation in JavaScript for this function, which is not that hard, honestly. Right, so which is not that hard. We can basically grab the pixels, right, so, and just like save them somehow. I'm actually surprised that this entire code compiles to WebAssembly without any modifications. That is pretty cool, right? That is pretty cool. Okay, so I can fuck with that. So WASM to what? So let's do WASM to what? Let's actually, generate some text in here. We probably want to do that in makefile. So let me see. Main what? WASM to what? And what we're going to do is going to be WASM to what? So main WASM, we're going to redirect main what? And let's do make main what. Right, so, and let's take a look at what we have in here. STB, fascinating. So do we have like a main function? We don't even have a main function. I think I know what the fuck is going on in here, because we never exported anything in here. Anything was ever fucking exported. What is what? It's a WebAssembly text. Right, so it's a textual format of WebAssembly. If you ever wondered how WebAssembly looks like, this is WebAssembly. And this is specifically WebAssembly text. You can even program in this language. We even did that on the stream. We even did that. So like manually programming, and it's not that hard. It's actually easier than x86-64 assembly. Because it's just a stack machine. It's a very simple stack virtual machine. So yeah, so there is a vprintf. I wonder how does it export any functions? It exports memory. It exports some. That's the only thing it exports. So what does it import? Okay, so I have a feeling that a lot of the things got optimized out because we never exported them. One of the things we can try to do, we can just say, export, or maybe extern. Is it extern? I don't remember which one it was, because, okay, so let's take a look at the C3 demo. One more time. Where is the demo C3? So some of the functions, yeah, so extern main, okay, so this is what we can work with, I suppose. This is what we can work with. Maybe I can even put that into the main in here, look at that. Okay, so let's try to make this entire thing. Okay, now we're fucking talking. Finally, it did, okay, so it didn't, all right. Understandable. Fucking understandable. But at the same time, we want to be able to use the math module, right? So from C3, because it's kind of convenient. Finally, errors, exactly. It's kind of convenient. So I can get rid of these errors if I just say, okay, we're not using standard library, but the standard library is kind of convenient because in the standard library of C3, we have such module as math, right? So if you find a file with the name main, right, so something like this, this is not how it works. It's not main, it's math, right? So it's math. Right, so let's actually find file at that. So this is actually rather convenient. I would like to actually keep it, and I would want to be able to use that in WebAssembly. So maybe what we can do, we can instruct the linker to not give a shit about undefined functions. That's one of the things we can do. Isn't it interesting? I think that's kind of interesting. So this is something that we did in Olivet, right? So let me take a look at Olivet. For those who doesn't know, Olivet is just like a simple 2D graphical library. Right, for some reason, people are extremely fascinated by this library. I think it's one most starred library. And I don't fucking understand why, because it's so fucking stupid. It's the stupidest library I've ever implemented. And technically, there's nothing particularly impressive about this library. But for some reason, people are just like insanely fascinated by that. So yeah, I understand. So this is one of the problems that I have as a content creator. A lot of things that I find interesting, actually deep and insightful, people don't give a shit about that. Some boring ass shit that is kind of trivial, people get fucking crazy about it. And I like, it's not like that I think that people are stupid or anything like that. Like, I personally don't care. It's the problem that I don't have an ability to predict what's going to be popular among those people, because I have a huge gap in what I consider interesting and what they consider interesting. It's not like, okay, oh, they don't understand me or anything. It's just like I lack an ability to predict what's going to be interesting for the majority of the people. That's what bothers me, actually, right? So yeah, for some reason this piece of shit is popular, so whatever. And in here we have I think a way to compile WebAssembly things and also instructing the linker to ignore undefined functions. So I would like to maybe steal a little bit of a code from here. So I think the name and the logo are the least part of the success, are at least part of the success. Nah, I don't think so. People don't really talk about the logo of this project that much. So excuse me. So let me see. Where do we compile these things? So there should be wasm. Yeah. So build wasm demo. So there is a function build wasm demo. Where is it defined? Here is where it's defined. So in here we're using target. We say no standard libraries. No. So then we exporting a certain function, but we do that through the linker because the language itself, C language, doesn't enable us to export certain functions. So this is the most interesting flag that I'm after, right? So allow undefined. So I think what we have to do, we have to pass this flag to the linker through C3, and it will actually allow to have undefined functions, right? So let me see, where is my make file? So this is a floor and ceiling. And to pass to a linker, we have to use the Z flag, or as you can see here, we have Z, and this is the export table, and Z and allow undefined. Okay, so let's try to recompile this entire thing and see if it's going to work or not, right? So hopefully it is going to work. There we go. So it worked. Essentially, if I understand correctly how exactly it works, it basically allows you to specify undefined functions. That's what it does, right? So if one of the functions are undefined, you have an opportunity to supply the implementation for these functions via JavaScript. So, and this is precisely what we want in here, actually. This is precisely what we want. So we can even take a look at the, yo, that's, look at that text. It's almost like a megabyte, right? It's a half of a megabyte actually, right? But still, yeah. Okay, look at that. Isn't that beautiful? Right, so we export in fmod, fmin, fmax, precisely everything that the linker was complaining about, and also stbi image png, which is exactly what I was talking about. Right, so this module just expects us to supply all of these functions through JavaScript. Right. So, and this is probably exactly what we're going to be doing right now, I suppose. So does it, yeah, it exports memory and it exports main. That is very fucking cool. That is insanely cool. I really like that. Anyways, so let's maybe create like a, I don't know, index HTML, right? So let's create the index HTML. Let's do a little bit of a HTML programming. Do we have any HTML programmers in the chat? HTML is the programming language of the future. Am I right, fellow programming humor subredditors? Isn't that funny joke? I'm sorry. Let's do HTML. Funny joke, HTML programming language. Ah, so fucking funny. Ah. Guys, I'm programming in CSS. Oh. So fucking fun. Oh, write a website in assembly. Ah, ha, 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 ha. So, tilt, yeah. So now, what we have to do, we have to have like a JS file, I suppose. We need to have a JS file. All right, so let's do a little bit of a console. Hola! And here I'm going to say hello world. Hello world. Script src index.js. All right. Oh, fuck. Fuck. We are doing WebAssembly, which means that we'll have to have, you know, the web server and shit. So yeah, let's use Python. Python 3m HTTP server 69 or 69. Let's go. So what do we have in here? Excuse me. Okay, so here's the hello world. Right. So and it tried to load favicon and it didn't work, obviously. All right, so what do we need to do in here? We need to load the WebAssembly. I think I can actually steal some stuff from Olivet's. I probably want to actually put that in the references because this is one of the things I was using right throughout the development, right throughout the streams. So I'm gonna actually put this stuff in here. Right, so because I think it is important for people to know about this entire thing. So in all of that, so here's the index.html, and where is the JavaScript? Is the JavaScript located somewhere in a different place? I think, oh, okay, so there's a VCJS, right? It's a virtual console, if I'm not mistaken, right? So, and oh yeah, here it is. So here's the JavaScript, and here is the virtual console JS. So this is a very important function, make environment. We'll need it at some point. It basically creates a proxy and allows the undefined functions still work. Right, that's kind of important. The first thing we probably want to do is instantiate streaming. Right, so we want to do WebAssembly instantiate streaming, and we want to fetch the WebAssembly path and also make environment, and so on and so forth. In fact, I think I'm going to just grab this entire thing and maybe put it somewhere here. Right, so does await work at top level? Does anybody know? Or do you have to do something like a sync, right, some shit like this and actually wrap this entire thing like that? So, so I don't know. Well, let's actually do that nonetheless. Right. So let's put it in closure, and so here we're making an environment, and I might as well actually just demonstrate the reason why you need to make environment, right? So I'm going to create an environment absolutely empty. So the wasm path is going to be equal to main wasm, right? So, and after the WebAssembly module has been loaded, we're going to just basically print that WebAssembly module. Right, okay, so do we include this entire thing through, yeah, that we do include that. Okay, let's go. Let's refresh this entire scheiße. Okay, so this is what I'm talking about. fmodf function import requires a callable, right? So you have to specify the implementations of all of the functions now, right? So fmodf, fmax, and also stb image, and so on and so forth. One of the tricks that I'm using all the time is using this special function make environment. So essentially it takes your environment, it takes the object that is supposed to provide the environment and wraps it into a proxy. So essentially if the WebAssembly instantiator tries to get like any function, it tells it that this function exists, but then it sort of like polyfills it with a thing that throws an error not implemented. So, which is rather convenient. So, especially if you have lots of undefined functions, you don't want to define them all, you can actually wrap this into a proxy and only implement the ones that are used at runtime. They don't have to be even used at compile time, just like whatever is used at runtime, you can provide only them. The rest of them are going to be basically polyfilled with not implemented. So it brings the compilation errors into runtime, sort of speak, if that makes any sense. So now I can just say make environment, right? Environment, like so, and it should instantiate the WebAssembly module. There we go. So we instantiated the WebAssembly module. So, and we have a bunch of exports in here, and here are the things that are exported. It's the main function, the memory, and some other shit that is provided by LLVM. So the thing that we want to call in this specific case is probably main function, right? So by calling it main, we basically execute the program. So let's go ahead and try to do that. So it's going to be instance, right? So w instance exports. Exports and main, and we are calling the function. So what probably will happen, it will first of all generate the image in its own internal memory, and it will probably call to one of the functions like fminf and fmax and so on and so forth, and that will crash there. So we'll have to implement those functions. Right, there we go. So it actually called many times. So this is very bad. So in case of not implemented function, it just logs an error. I think one of the things we want to do in here actually is throw a new error like this. That's probably what we want in here, right? So we can say prop, right, something like this. So here's the properties, and here is the arguments that were provided. So basically it will stop at the first one, right? So let's just throw this entire thing like so. Right, so let's refresh this entire stuff. Oh my god, it keeps actually piling them up. Freaking browsers, like, and it's impossible to stop this motherfucker. Like, I'm telling it, refresh. No, I need to dump them all first. I can't stop. I need to dump all of these messages first. Stupid web, I swear to God. I just freaking can't. All right, let's take a look. This is exactly what I wanted to write. So it crashed on fmodf. Right, so let's go ahead and implement this function, right? So let's have fmodf. Right, fmodf, and it's going to accept, I suppose, just like x and y. Right, so, and in here we can probably do something like this, right? So there we go. Minf, very easy. Minf. I might as well even say, okay, math min. Anything else? Max. Okay, so this is gonna be max. What else? Ooh, this is cool. Unreachable put char. It's trying to print shit. Huh. Unreachable put char. Let's go into the standard library. I suspect some piece of Scheißung. I suspect a piece of Scheißung. Vim grep put char. I can smell some piece of Scheißung. Smell it. Smell. Where is it? Where is it? Okay. Yes. So it actually goes through the libc to just print some. So, and we're not linking with libc. Right. Right. So the C3 WASM is already a stable feature. I don't think so, actually, but I mean, we don't fucking care. C3 is not a stable feature. Talking about stable features while talking about C3, statically linked musl. I mean, musl calls to Linux syscalls. It doesn't solve any of the problems. So it's not about that. Why does it use put char? That's the real question. So, because we use vprintf. So, yeah, I see. Do we actually output like characters somewhere in the code? Oh, we probably, yeah, it probably uses put char specifically for fs and some other shit. Okay, so when we do printf, honestly, can I just say fuck you, Leatherman, and just like comment out all of that stuff? I'm pretty sure I can do that. So let's do make. So here we're generating everything. Okay, so let's just do make minus b. So why did you fail, mother flipper? Program linked main error 34. Are you okay, my friend? What the fuck was that? What the fuck is that? All right, so I'm gonna just only make WASM. All right, yeah, there we go. So let's refresh this entire thing, and that's it. So it just worked. It just worked. But I think one of the things we need to do in here is actually try to call stb write png. Right, I think it makes sense to do that. So let me actually remake main.wasm. Right, so, and I'm gonna try to refresh, and look at that! We got stb write png call. You know what we can do? On that call, we can grab the bytes of the image that were generated within the WebAssembly and put them on the canvas. Put them on the canvas. So the program thought, very naively, that after calling stbi write png, it is going to save the image to the file system, but we tricked it. Fucking tricked it. We're gonna take its pixels and we're gonna put them on the screen in a fucking web instead of the file system. Right. So that's what we're gonna do. So that's my plan, actually. That's my plan. So let's go ahead and do that. I think it's gonna be interesting. So we shut up. All right. So let's do a canvas. Let's do a canvas. Can in the ass. So this is gonna be canvas, scamness. So what we're gonna put in here, I suppose, is gonna be game, right? So this is gonna be canvas game. Right, and let me go into the index.js, and here document get element by ID game, right? So here we're gonna do game like this, and I suppose if game is equal like null or something, we're going to throw an error. Right, no canvas with ID game was found, like this. Maybe to save little space, I'm gonna create a single line, and then we're gonna do ctx, right? So ctx equal to game get context to D, right? So to just make sure that everything works as expected, I'm going to print the context, right? So here is the context. We've got the canvas rendering context 2D. 2D's, that's oh, so, and in here, let's go ahead and just implement the whole thing. So essentially, every time the WebAssembly module calls STBI write a PNG, we're going to be just like updating the canvas, right? So that's going to be basically the idea. Hopefully, we'll see how it goes. All right, so what's the signature of STBI image, right? So we have these kind of things. These kind of things. We have file name, right? We have W and we have H. We have amount of components. We have the pixels, which is the data, and stride and bytes. Right, so one of the things we can do in here, I think, is that we can take the canvas of this entire thing and set its width and height to whatever was passed through STBI write PNG. So for now, I can just do something like through error to do, right? So it's not implemented yet, but one of the things we can do, we can just resize the canvas to the size that was set you know, from within the WebAssembly module. So let's go ahead and refresh the entire thing. And one of the things we can take a look at, the size, and the size is actually 480 and 270, which is exactly the size of the image that is generated by WebAssembly module, right? So we can even confirm that by taking at the size of that generated image. So here it is. Here is exactly the size. So we're correctly receiving the information from the STBI write PNG call. All right, so that's pretty cool. The next thing we need to do, we need to now get an access to the pixels, right? To the bytes of the pixels. They are located in the WebAssembly memory at that specific pointer, right? They're located there. So we can even do something like console log data and just, you know, yeah, just print that pointer. Just freaking print that pointer. Can I just do something like console? Yeah, there we go. So here's the pointer. So somewhere here at that specific place in the memory start the pixels of the image. So how can we get the access to the memory? I think we can use vc.js from Olivets and just see how we do that, because we access the memory there all the time. But I'm not sure how exactly we do that. So here is the buffer. Okay, so here is the buffer, and buffer, look at that. Look at that. So we take the WebAssembly instance, we take its exported memory, and we take in the flipping buffer. We take in the flipping buffer. Okay, so let's go ahead and do that. So that's how we get in an access to the memory. Right, so I can put it somewhere here. And then what we can do, we can create U8 clamped array out of that, providing the buffer and its position and its size and so on and so forth. I think this is precisely what we want in here. So this is exactly the code that we need, not the code we deserve, but the code that we need. Right, so here's the buffer. So this is the pointer, and this is basically the size. Right, so h multiplied by 4, maybe multiplied by the amount of components. Do we provide the amount of components in here? I'm pretty sure we do. Yeah, so this is what we can do. So width and height and amount of components, and we got basically an array. And we can actually go ahead and just flip and print that just in case, right? Just to see if it is correct or not. I kind of want to see that. I can see shit in this mist, but cannot read properties of undefined reading, blah, blah, blah. Oh, fuck me. In the ass. We don't have an access to W. Fuck. Fuck. Okay, so I suppose we can actually factor out the function, you know, STBI image, STBI write PNG. Right, so when we can just put that stuff in there, I think that's one of the things we can do. Right, this is what we can do in here. Let's go. And we can basically make this like a global variable, and in here we're just like assigning it or something. That's what we can do. Yeah. Because at that point, at the point when the function is called, W is going to be actually set to something. I think it's a reasonable way to do that. Oh, it's also W. Fuck me. Okay, so, but I mean, it doesn't really matter. Right, so we still had to do that nonetheless. All right, so let's actually refresh that. And what do we have? CTX is not defined. CTX must be defined. Fuck me. Oh, right. So... can we just like make maybe see? I remember there was like a kind of a way to do that. You basically do like you know, window something whatever. We can always do something like that. All right, so h is not defined. All right, so we need to do width and height. Anything else? H is not defined. Yeah, so we now have to do something like width, height. There we go. So we've got the bytes. Look at them. They actually look correct because we have quadruple of bytes, and the fourth byte is always 255. Look at that. 255, 255, 255, 255. What that means? Each quadruple of bytes is a pixel, and alpha of that pixel is full. So each pixel is opaque, which is exactly our case. So this data looks legit. This data looks legit. Let's go ahead and turn that into image. How about that? We just pass it. Yeah, so essentially pass it to image data, right? So we just do image data like so, and we also have to specify the width, right? So it needs to have the width to properly do that. And there we go, we've got an image, and we can now slap that image onto the canvas. Look at that, we're just slapping that image onto the canvas. Right, so let's actually go into the web page. First, mother flipping try. First mother flipping try. First mother flipping fucking try. Mother flipping fucking try. Mother flipping fucking try. So, the same code works both in native and WebAssembly, and it's actually the code related to the game. I think that's pretty fucking poggers, isn't it? I think it's so freaking poggers. I really like that. Interesting. What FPS boost will we get compared to TypeScript version? I think we're not gonna get boost right away because we're gonna be having a combined renderer, right? So we're not gonna rewrite the entirety of the renderer in TypeScript on today's stream, right? So we're gonna have some of the parts rendered in WebAssembly, and then some of the other parts rendered on top in TypeScript, so which at the end may result at slower experience. But then we're going to be slowly moving some TypeScript parts into WebAssembly, and eventually the whole render is going to be inside of the WebAssembly module, and I hope then it is going to be faster, right? So I hope then it's going to be faster. So yeah. That's pretty cool. That's pretty cool. That's pretty cool. So I'm thinking how I'm gonna be integrating all of that into the main game now. Right, so how I'm gonna be integrating all of that into the main game. So let's go into the coil. All right. So client MTS. So the background drawing took the longest from what I can say, so this may already be a huge improvement. Maybe, actually, I didn't think about that. I forgot that it was the slowest operation. Render, floor, and ceiling. So how do we call this entire thing? We actually call it on the back image data, right? So we call it on the back image data. So I need to probably find the interface display, right? And back image data is this. Interestingly. So the back image data is not considered to be. I'm not really sure why I'm using back image data as an image data and not as a U8 clamped array or something. Right. I'm not really sure why. Because if it was like a clamped array, I think it would have been easier to port this entire stuff. Right. I think it would be easier to port this entire stuff. So let me see how exactly I'm treating, like how I'm creating. Okay, I'm just creating image data with that specific size. So, and then after I finished rendering everything, right, after I finished rendering everything, I just display and swap back image data by directly putting image data in here. So I wonder how, when you create a new image data, right, new image data, right, when I do something like this, oh, it already moved in there. Is there any constructs? Okay. Does it create like a new copy of this thing, or is it just like a view over this entire stuff? So my idea as of right now, chat, my idea as of right now, replace back image data with U8 clamped array, right, and render everything into U8 clamped array. And then when you swapping it onto the canvas, only then convert it into the image data. That's my idea. And then once this entire thing is that, we can actually move back image data into WebAssembly. We can literally use the WebAssembly memory as that back image data. So imagine WebAssembly module renders into its own memory, and the TypeScript also renders into the WebAssembly module. That way, it's actually becomes easy to port all of the code from JavaScript to WebAssembly because they already kind of work on the same memory. So yeah, they already kind of work on the same memory, and just will become easier. So to do all of that, we'll need to do a little bit of a refactoring session, like maybe compiler assisted refactoring, where I just like literally do uint8 clamped array and just go through the compilation errors and stuff like that. So we already have like a 27 errors in here, as you can see, right? So 27 errors. So we'll probably have to fix that. But I already streaming for 1 hour, right? So I think almost 1 hour, right? So, and I think the time has come to make a small break and refill the cup of tea. And the chat is already telling me that it's time for a break. Okay, so let's actually do this compiler assisted refactoring after the break, right? And yeah, so. Okay, so let's go ahead and just go to the compilation errors. We have 27 of them, right? So let's see if we can even fix them. So how is, I think it's a fly check next error. Yeah, there we go. So it's a high. Okay, so this one is interesting. It holds width, right? So the problem with just using uint8 clamped array is that because we don't really have that information. So let's actually do back image width, which is going to be a number, right? So, and also back image height, which is also going to be a number, right? And this is what we're going to be using in here. Right, next error, back image height, next one height, and this one is gonna be, oh my, Emacs don't fucking, yeah, so it's just like LSP was trying to make a query or something like that, or whatever the fuck has happened, I don't know. Okay, so in here, what we're gonna be doing, so I suppose when you're accepting image data, I think what we can do in here is just that, right? So that's what we can do, and it's going to work. Yeah, it seems to be working, all right. So let's do that, and the next arrow, and then in here, like so. So int8 clamped array is basically like image data, except with a slightly different interface. JavaScript likes to do it like that, right? So it has shit ton of different objects for working with binary data. They all kind of do the same thing, but they have slightly different interfaces because fuck you. That's why. So yeah, so this one is gonna be, can I create new uint8 clamped array? Is that a thing I can do, or is that purely view? A typed array of okay, so constructor accepts length, which is nice. All right, so that means we can do something like width multiplied by height multiplied by 4. Right, so that's what we can do in here. Right, and then we can do back image width. All right, so which is going to be width, right? So in this one is going to be back image height, which is going to be a height. Right, so, and this thing is uint clamped blah blah blah. So this one is rather interesting. So we fill with 255, and I think I can fill you know, u8 whatever. So in here we are creating new image data like so, but we also have to provide the width, and the width is going to be display back image data, back image width, I would even say. So we still have 10 errors in here, which is, I mean, fine. Right, so we still have to fix those things. You know what? I can just query replace this entire thing like so. Alright, so I can do something like this. Boom, 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 boom. Can you fucking beam do that? I don't fucking think so. Fuck you. Sorry. Alright, so fly check, next error, and so now I need to do the same thing for the height. All right, yeah, so what's the next thing? Data. Maybe I can just do something like this. Look at that, I can. Insane, bruv, insane. All right, so this is when I'm rendering floor and ceiling, I think what I have to do, I just have to provide the display. Right, so this is going to be just the display like so. So, and as you can see, yeah, so we have to replace image data with display back image data like so. Boom, 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 boom. I want you in my room, spend the night together in my room. So, and then I can now query replace more things in here. For instance, like back image data height, like so, and it's gonna be just like this. Boom, 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 boom. Alrighty. Anything else? So now we have to do the same thing for the width. Query replace something like that. So this is good. You can't see scheisse in the smooth, but I mean, I really apologize for that. So let's query replace. This is going to be width. This is going to be width. Can you see? I think you can see a little bit of a scheisse. Just a tiny bit of scheisse. So we have a bunch of data. I think this is the last thing we need to do in here, honestly. Yep. So I think we successfully refactored this entire thing. I think we literally successfully refactored this entire thing. I think we did it. Okay, so I can try to do the full rebuild just to see if there are any errors outside of the current module. So I don't think there are. Yo, new minor version of NPM available. Do I want to upgrade? Do I really want to upgrade my NPM? Who am I? Some sort of like soy dev that constantly updates his setup? No, I'm a professional software developer who values stable software. So let's go ahead and just go in here. So let's do npm run. I guess serve, we're gonna serve it. All right, so I'm gonna go into the local host. I'm looking at the wrong thing. Where's the, yeah, I still have a Python script working. I still have Python script twerking. Long twerking Python script. I think it works fast. Wait, what the fuck? Wait a second. Why does it work fast? I mean, I don't fucking know, but I mean... It didn't make it worse, per se, honestly. So, does it actually use the new one? I think... Right, so... Let me refresh with the caches enabled and shit. Yeah, that's fine. Let me take a look at the source code. Source... Client MGS. Can we find the display? So, for example, back image width. Okay, so we're in fact using the new code, right? So we have references to back image widths and stuff like that. It is working, so I just replaced image data with a uint clamped array and stuff like that, and it's working. It's actually working faster than it was before, so that's pretty cool. Stash changes and compare. Okay, let's give it a try. Sure, why not? Why not? Why not? Why not? So let's give it a try. So I'm gonna stash this meta flipper and then I'm gonna rerun it. So let's refresh it. Yeah, it's not going into 50s. It's like stays at 30. Yeah, but that one was sometimes going into 50s. That's what's funny in here, I think. Alright, so I'm gonna pop the thing. And I'm gonna try to refresh this entire thing. Yeah, it goes over 30 and sometimes to 50, so it's slightly better. I wouldn't say it's like a super fast, but it's slightly better. Yeah, I think it is slightly better. So, but I mean, it's not the goal, right? So it's not the goal to. What we're doing, we're just like preparing to simply use the memory from WebAssembly. JIT kicked in, maybe. Oh, by the way, I heard that there is a lot of optimizations associated with uint clamped array, right? So because it's so close to how memory works. Maybe some locking is mitigating. Maybe, who fucking knows? Who fucking knows, my friend? Maybe that's exactly what's happening in here. But anyway, so let's actually go ahead and just like, commit what we have. Right, so use uint8 clamped array for back image data instead of image data. We are preparing to render into WebAssembly memory, right? Which is usually viewed via uint8 clamped array. Alright, so, and I'm gonna push that right into the repo. Rejected. Alright, so let's actually stash and fetch the latest thing. I think I didn't fetch the latest things. I think that's what happened. Let's take a look at the history. Yeah. Where's the origin main? I don't see origin main. It's somewhere. Why is it here? Chat, I'm confused. So what origin is pointing at? I recently renamed the repo. So that's basically what happened. Oof, I probably broke the repo for everyone who had a fork for it, but I mean, yeah. So let's reconfigure the repo. Let's reconfigure specifically, maybe I might as well just like remove this one. And yeah, so reconfigure this one, right. I mean, you asking me to set it? I wanna just copy. Jesus, this is so inconvenient. This is dumb. This is the dumbest UX I've ever seen. What I wanna do, I wanna have a string that the string of the previous repo, so I can just replace this thing, and it asks me to retype the entire fucking remote origin URL. What the fuck is this shit? This is so dumb. This is the dumbest experience I've ever had in my entire life. Right, so I just want to rename it. Right, so URL. Enter a new... I want to fucking edit it, you motherfucker. Jesus. So fucking dense. Who fucking designed that? Who fucking designed that? I swear to God. Sorry. Right, so let me fetch the latest stuff. I just fucking can't, man. I just fucking can't. Alright. So let's actually rebase on top of this entire thing. Elsewhere, origin main. Fuck. Fucking conflicts, mate. Fucking conflicts. Alright, so what do we have in here? Or is that a really conflict? What the fuck is like you... What is this code? I don't remember this. So revert buffer. I see. So this is the... Oh yeah, so what essentially we have to do in here is just this. Alright, so do we need to do anything? So rebase continue. Yo, it worked. It fucking worked. Let's double check everything. So we're gonna npm run build just in case, right? Let's double check that I didn't break anything while resolving the merge conflicts and stuff. Right, so let's do surf. And yeah, so let me see. Seems to be working, seems to be working. That's very cool. That is very cool. Okay. We can live with that. We can live with that. So let's actually now try to push the whole thing. Okay. So yeah, that's pretty cool. How we're going to organize the interface of this entire stuff? I think what we have to do is instead of creating the new uint8 clamped array, we have to instruct the WebAssembly module to allocate the buffer, right? So we're telling the WebAssembly module, okay, so this is the size of the buffer that we need. And it will pre-allocate that buffer. We'll also need an ability to get the pointer to the beginning of the buffer, right? And then we need functions that render the floor given the position and rotation of the camera. malloc, I don't think we'll need to rewrite malloc because there is an allocator within C3 standard library. Within C3 standard library. All right. So now let me see. 20 milliseconds to local thread would be absurd. I don't know what you're talking about. You're talking about the current state of the game. The game isn't finished. All right. So where is the main C3? We need to. So we allocate the buffer in here, right? I'm thinking, what if we do it like that? Right, so essentially we're gonna have a special function that resizes the buffer or allocates the buffer, right? Allocate buffer, and it might actually return the pointer to that buffer, right? So allocate pixels. Yeah, so we're gonna provide the width, which is gonna be int width, int height. So, and what we're gonna be doing in here, we're gonna just pre-allocate this entire thing. So I'm surprised mathcons works. That wasn't an import, right? I think it uses the LLVM intrinsic. So we can take a look at the what, right? So cosine. Do we need cosine or sine? Do we use it anywhere, cosine? Camera update. Maybe it. Oh, okay, I see. It just got optimized out. It's just like folded the constants. That's probably what happened. Anyway, whatever. Let me focus on what I need to do. Jesus. All right. Where's the allocate pixels? Okay. Right. So we're allocating the pixels. We need to go to here, C3. There was some stuff for memory, if I'm not mistaken. So there's new, right? So you can allocate a new type, so which is fine. Right, so new array, which is also understandable. So you can just allocate a bunch of things in here. And what does it return in here is rather interesting. So it's from the allocator, new array. Like, what's the return type, bruh? So maybe that's what we have to do. So we have arena allocators, dynamic heap allocators on stack, temp allocators. Okay, so new array. Where is the definition of new array? Do we have it anywhere in here? New array. Give me the definition. I want to take a look at its implement. It's not even implemented in here. Okay. What does it fucking return, bruv? What does it fucking return? New array. So, but it's I mean memory allocator. New array. Oh my god, so fucking many indirection layers. All right. So it returns you a pointer or something, right? So new array try. Right, so we allocate a bunch of things and so we casting it to a pointer to the type, and then for the pointer we're taking this kind of thing. So yeah, all right, so I suppose that's what's going on in here. That's what's going on. All right, whatever. So let's just go ahead. Maybe I can do mem new array. All right, new array. C3 new array, and it's the elements. So the type is going to be the color, and the elements is just width multiplied by height. That's what we have, and I suppose this is what we can do, pixels. And let's just, can I make it like this? That's what's interesting in here. That's what's interesting. Okay, so let's go ahead and just compile this entire stuff and look at the compilation errors. In terms of compilation errors, okay, so all of that is supposed to be U size. Understandable. Let's make it U size. Anything else? Missing return, that is understand. Okay, so let's not do any return for now, because like what I'm trying to see if this, okay, so this is perfectly compilable. So this is viable, this is compilable. All right, that's pretty cool. So, and interestingly, right, so pixels, right, we probably want to have things like U size, pixels width, which is not set to anything, and pixels height. Right. So afterwards, we want to maybe allocate pixels. So I'm creating this function because this function is going to be called from the outside. It would be called by JavaScript to pre-allocate a buffer of a certain size. That's why I'm doing all of that stuff. Right, so and in here we just do pixels width equal to width and pixels height. Pixel width and pixels height. So that should break some stuff, hopefully. Hopefully it will break some stuff. I'm gonna go to the compilation errors and fix all of that. Let's go. So every time, like at 64, right, so we want to replace height with pixels height, like this. Anything else? So what we have in here is a 64. It didn't like height, which is rather bizarre, isn't it? So this is because usize cannot be implicitly converted to... Oh, it's... okay, can I just like do an integer then? Annoying. 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 All right, so let's use it as an integer then. Right. So, and in here, that means like this. Let's use it as an integer as well. So, and in here, just cast this entire thing to use size. So it's just like the least amount of casts that we need to perform. All right, so, and in here, let's replace width with pixels width, right? So with pixels width. All right, so can you use -1 as the error value? What the fuck are you talking about? All right, so what do we have in here? Everything seems to be compiling, and yeah, allocate pixels, it allocates them. So let's actually see if it generates the image, output PNG. Segmentation fault, that's actually pretty cool. I'm really happy to see that, honestly. Though I wouldn't expect this thing to be like that. Right. At which point it happens, though? So it doesn't print the stack traces. What's interesting is that when I build C3 from scratch, it doesn't print stack traces. I wonder if that's because I compiled it incorrectly, or maybe something else. Maybe there's a special flag or something. You are with 05 own, so what? It worked with 05 before, so what? Again, so what? So what are you all on about? It worked with 05 before. Not print stack trace with 05. It printed with 05 before, maybe? What are you all about? Like, it worked before. What? People, stop. You're annoying me. Okay, I'm gonna stop listening to the chat. So, all right, what we have? I need to figure out what exactly is going on here, why it fails and where it fails. All right. So yeah. Maybe we can do a little bit of a GDB. All right, so G. So let's actually do that, and maybe in here. Let's go in here. So teamux, okay. GDB main. All right. So I just want to take a look at the stack trace. Ooh, interesting. So it's when it tries to save. Okay, I see. Something with PNG, save into PNG. So if we disable save into PNG, right? So it might actually work. All right. So it doesn't like this kind of stuff. All right. Fair. Unironically fair. If I try to do something like this, will you work now? Oh, okay. So fech output PNG. All right. So now if I try to rotate this stuff about like a direction equal to half. So that's interesting. Okay, so when it rotates, which is perfect. It silently casted to wrong pointer, I guess. Maybe we should report that, but I mean, I'm in the flow. Somebody else please report that. I'm not going out of the flow. Okay, so we allocated pixels and stuff like that, so that's pretty cool and everything. What else do we want to do in here? So there is a little bit of problem that we need to synchronize the this kind of stuff. All right, so we allocate the pixels. We may return the pixels themselves, right? So we may return the pixels themselves. That's totally fine. And after that, I need to be able to render the floor, right? So render floor and ceiling. And here we pass in the camera, but within the camera, we only need its position, all right? So we only need its position and also direction. We don't even need direction. That's funny. We need direction only for FOV, right? So FOV left, and we don't even, yeah, we do need FOV right. Okay, so I have the following idea. What if I accept the position, but position as X and Y, so it's easier to call from JavaScript, and also direction. All right, so like this. So this one is going to be position X, position Y. So I'm making the interface super simple intentionally. And FOV left and FOV right are going to be computed based on that. So that means I want to get rid of the camera, basically, I think. All right. So let's get rid of the camera. So it's going to be struct camera, fuck that. All right, so let's go ahead and just like go to the compilation errors. What do we have in here? So camera update, right, so in terms of camera update, we'll need to move this entire logic to probably here. Oh, I already moved it. Okay, so I don't know what the fuck was wrong with me. So this one is vector2, vector2. So I can even query replace camera position with just position, which is kind of meh, but I mean, oh, wait a second. I have an idea, like, why am I removing the notion of the camera completely? If I can just construct the camera out of this entire thing, so I can do camera, right, so I can say position is basically this, position X, position Y, and the direction is direction, right, then I can simply do camera updates. Emacs is so annoying. Okay, so this is update and that's it. Right, so did I remove the camera update? Yes, I did in fact remove it. Oof. Fuck, I should have not I forgot that I don't have Git in here. Yeah. Okay, let's go back. Let's go back in here. So this one is the camera, bruv. So this is direction, camera update. Come on, you can do that. Okay, so let's try to go to the compilation errors now. Could not be found. So yeah, so I should have not removed the camera. So, but this is fine, right? So because that's what you expect when you're experimenting in a flow, right? So this is a direction. Then you have vector2 FOV left and FOV right. Like so. There we go. So what do we have in here? Definition was here, blah blah blah, 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 blah. Nobody cares. Okay, so here is the 0 0 0, whatever. So we don't need a camera in here. Okay, cool. What else do we have in here? So everything seems to be working. Okay, shut up, Emacs, shut up. So render floor and ceiling. So this is already kind of usable for WebAssembly. We can make this external thing. I would like to maybe even rename it to something more like pleasant. Right, render floor and ceiling. Boom, boom. Okay. So render floor and ceiling. This is an external thing. All right. So this is a render floor and ceiling. So this is WASM. There we go. Render floor and ceiling, and allocation also going to be like that, right? So it's basically extern. All right, so this is going to be WASM like this. So this is two functions that are going to be exposed to JavaScript. So the JavaScript will pre-allocate the buffer of a certain size and will get a pointer, so it then can construct uint8 clamped array. So, and it's going to be the array that is both viewed by by WebAssembly module and JavaScript, so it's kind of shared. Right, and then JavaScript is supposed to call this function to pre-fill, this memory with the floor and ceiling automatically. So that's how it's going to work, I think. I think that's a good way to think about this in testv. Right. Schmemming, yeah, basically schmemming, essentially schmemming. Essentially schmemming. So I think it's ready. Essentially, it's basically ready. We should start integrating it into the coil. All right, let's go. So how I'm going to call this particular module? Or is it going to be just called mail, right? Or should I call it something else? I think I can call it just a renderer for now, or render. Right, so this is going to be a renderer. And when I'm building the shice, how I'm going to be approaching this entire thing? So I can... So yeah, I don't want to introduce too many build systems. One of the things I can, so we have a surf in here, right? We have surf. I can introduce build.js. Right, in a surf.js, right, in a serve.js, we have this kind of stuff. Right, so it has a CMD and it enables us to run all of these commands. I might probably actually extract it to a separate module of some sort. Right, but we'll see how it goes. So yeah, and in here, when I'm compiling everything, obviously I'm going to be doing TSC, right, so without any arguments. And then I need to do C3C compilation now. Let's go into the make file. Where is the make file? Here it is, and we are compiling. By the way, this one is rather interesting because it also uses deplatform, but I mean, it's not really needed per se. Okay, so let's query replace basically any chunk that is not space, right? So that is not space. And just wrap it in parentheses like so. Also find anything like this and just split it by commas. And this is what we've got. So I'm gonna put this stuff in here. So that's how we're gonna be building shice. Right, so this is a compile. All right, so this is one thing. This is another. This is another. So this is a target. There's a bunch of other things. So, and this is main C3, so this one is a renderer. All right, so this is going to be the renderer. and this one is going to be the renderer. So interestingly, in a package.json, when I'm saying build, we should actually call build.js, like so. So first we're going to be building TSC, and then we're going to be building the web, like WebAssembly. So that's how it's going to work. That's how it's going to work. Okay, so let's go ahead and just try that. So npm run build. What do we have? So is it building? Yeah, assuming non-POSIX environment. Let's go. So, and that created render wasm. Okay, so let's go into the client MTS, and maybe index.js. So we need to bring the make environment thingy in there. Make environment thingy in there. So here it is. Yeah, this one. Fuck off. So this is a function that I suppose returns a proxy, right? So it returns a proxy. Cool. But a proxy probably it doesn't know what is a proxy. Oh, interesting. So proxy constructor. Is it? Yeah. So it's a proxy of an object, I suppose, right? So and this thing is an object. How do I, because environments are just a bunch of functions, how can I make it work? How can I make it work? Can I just say any for now? Or just any? Consider wrapping it in string. Okay, that's very funny. So what you don't like here implicitly has any. Well, I mean, okay. And what you don't like in here? Nah, could not find envs. But here it is. Envs is declared, but value is never read. Ah. Okay. So target is value that is never read. Okay, can I just do something else? Okay. Okay, cool. So let's actually fetch the wasm. What's up? Ooh. Main extra renderer wasm. So what do we have in here? So it's supposed to be like a WebAssembly. So X, what you don't like in here? So yeah, it's gonna be something like this. STB image right, we don't care. We don't care. And this is what makes it so goddamn interesting. Because I think this has to be part of the game. Right, it has to be part of the game. So that means I need to do all of that stuff when I create the game. Yeah, so definitely. Let's move all of that stuff into create the game. We're gonna put in here, and so we're gonna treat this entire thing as a resource, so to speak. And in the interface of a game, we're gonna have a wasm, right? So wasm, which is a WebAssembly. So is that, or maybe a WebAssembly instance? Instance. Finally. Okay, so create game. Right, and when I'm constructing this entire stuff, when I'm returning the game, game equal, we just put wasm in here. Is it going to work? Fuck. So what you don't like in here? What you don't like? Missing instantiated source, but okay, WebAssembly instantiated source. Is that how you spell it? How the fuck do you spell it? Instantiated source. Fuck, they move from fucking. Instant. But don't freaking tell me that I have to do some stupid. Oh, okay. It's because of T. Couldn't find name. Are you telling me? Anyways, so WebAssembly instantiate streaming, blah 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 blah. So we don't have any errors anymore, which is nice. I really like that. Really like the fact that we don't have any errors anymore. Okay, so when I create display, right? So when I'm creating the display, I probably need to allocate source. I need to make a small break because I really want to pee. So after the small break, we're going to continue integrating the module. So we basically need to just allocate the buffer and stuff like that. Okay. Okay, we're back. We need to pass wasm module to allocate in the back buffer, right? So when we create the display, right? So as you can see here, we create the display. I need the wasm module. I need the wasm module. I need the fucking wasm module. Give me the fucking wasm module. Okay, so we can pass it in here. So wasm WebAssembly. So WebAssembly instantiate. Yeah, instantiated source. Right. So we're gonna be putting it in here. How are we gonna be approaching this entire stuff? So here's wasm. So and it's an instance exports. And usually I can get the memory, right? Can I get the memory? I think I should be able to get the memory. Where is the code? Yeah. So I want to take the buffer, right? So here's the buffer. And once I have the buffer, I want to create uint8 clamped array. So maybe I can save that into the buffer like so. I can do wasm instance exports, and if I call function, right, so it's going to be allocate pixels. I'm calling to this function with it C3 module, right, this function. So, and I'm going to be passing width and height in there, right, Jesus Christ, width and height. So this thing must return me a pointer, right? So let's actually call it like a pixel pointer, right? So this is a pixel pointer. And once I've got the pixel pointer, maybe I can even say that it's a number or something like that. I should be able to construct uint clamped array, right? So out of that, let me see. So it's index.js uint clamped array. So I provide the buffer, right? So I just provide the buffer, and I think that is basically it. So it complains about like these things and these things, and this is because TypeScript is stupid, right? But it is what it is, right? So it is what it is. So, and do we even? Yeah, we have to provide the pixel PTR. There we go. Pixel PTR, and is that it? I think that is basically it. So I didn't really know how to tell it that these things exist, right? So the buffer does not exist export functions. Yeah, it's kind of stupid, but it's just like is what it is. All right, now if I try to compile the whole thing, will it do that? It's taking some time. All right. So it complains about a couple of things. But that's about it, right? So the thing about TypeScript is that it generates things nonetheless. Right, so, and this is something that we want to put in here. Oh man, okay, so we have to pass wasm like this. All right. So there should be only two compilation errors. Only two compilation errors. And if we only have two compilation errors, it's going to be perfect. Okay, so it's buffer and the function not callable or whatever. All right, so I think we're ready to go. Right, I think we are in fact ready to go. So npm run serve. All right, so we are serving. Ah, fuck. Okay. What do we have? Let's take a look at the errors. Memory access out of bounds. Ooh, that is actually very fascinating. I think I know why. All right, so because renderer C3. Okay, that's very bizarre. Why it is like that? So it's trying to access out of bounds. Buffered too hard. I don't think so. So let's actually go into here, find this entire thing, and just maybe print, maybe new error. All right, so something like this. Pixel PTR is a pixel PTR, and I'm gonna just throw this entire stuff and see what we've got. See what we've got. So I'm gonna rebuild the whole thing. Rebuilding the whole thing. So it's complaining about something. Not sure what is that. What's that? Oof. So this thing is possibly null. Oof. Ah, this is because of the throw. It short circuits the control flow, so some of these things are not available. Fine. That's totally fine. I don't care about that. Excuse me? This is not what I want. Bro. Ah. Ooh. It's trying to print some shit. What? Okay, why are you trying to print some shit? So why do we need to print anything, right? So printf. We don't really. Okay, so let's get rid of all of that stuff. You know what? It's probably trying to print an error of some sort because panic prints. Okay, so it panicked probably. Okay, so that's understandable. That's understandable. Oh boy! Oh boy! Oh boy! Oh boy! Oh boy! Okay, so let's get rid of all of that. Right. So yeah. So that seems to be compiling though. That seems to be compiling. So does it fail because I don't even know why exactly it fails when we are trying to allocate. So it's probably fails because we're trying to allocate some things. That's probably why. Maybe new array fails, maybe. which is understandable, right? So it would be nice to know where it panics or something like that. But anyway, so one of the things we can do, we can get rid of the dynamic allocation in here, right? Let's get rid of the dynamic allocation, sure. I thought it's going to be kind of cool idea that the JavaScript provides, right? So like how much it allocates, but apparently it's a bad idea. Okay. So let's go to the client MTS, right? So here's the factor, screen factor, blah, 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 blah. All right, so we've got that, and we just, you know, we're gonna be pre-allocating this into stuff. So we're gonna get rid of this, and screen width multiplied by screen height. So, and build JS, I'm gonna get rid of that so it speeds up a little bit, and let's just try to run it. Okay. Yep, so mem array, we're not gonna be, okay, so let's just return a pointer to this thing. Right, we can take a pointer maybe to the first one, right? So are you not happy? Okay, so let's query replace pixels width with screen width, boom. Pixels height with screen height. Okay, that was easy. Alright, fair enough. So allocate, so it doesn't really allocate the pixels, but it returns the buffer nonetheless. So, okay, let's refresh. Okay, so yeah, we've got the pointer and everything seems to be working. So let's go into the client MTS, pixels PTR, let's not throw anything in here, right? So let's go into the build.js and let's rebuild the whole thing, right? So I want it to fail in two places, right? So we expect only 2 errors, 2 compilation errors. No more or less. Okay, so there's 2 compilation errors and they're fine. They're totally fine. Okay, so let me restart the whole thing. And I'm going to refresh the whole stuff. And it's working. So you know what's funny is that we're not using WebAssembly yet. We're just using WebAssembly module. But we're rendering using TypeScript into WebAssembly module. So that's the funniest part. So, but it works, right? So it seems to be working, so that means we didn't really break anything. So that's already pretty good. So render, floor and ceiling, blah, blah, blah. Let's not do that. The idea here is to now take the game, CTX or wasm, and just call render, like render floor and ceiling from WebAssembly, right? So this is the JavaScript version, and here we're gonna have a different one, the WebAssembly one, instance exports render floor, right? Render floor and ceiling. So, and this is the function written in C3. It is available in here, so we have to provide the basically X and Y of the position of the camera, right? So this is what we have to do. Game camera position X, right? So game camera position Y, and also game camera direction, and that will make it actually render things. Okay, so this introduces another compilation error, the third one. Right, so let's go ahead and just try to recompile and see if it's going to work now. So basically on the first pass, WebAssembly part renders floor and ceiling, right? And then the rest of the stuff is rendered by JavaScript. So it's a basically a hybrid renderer, if you can call it that way, right? So, but they operate on the same memory, essentially, hopefully. That's the idea, at least. All right, so I'm going to open this entire thing just in case I catch any errors, and it's working. It seems to be working at least. It's not faster per se, but it's working. Though it's pretty stable at 40 FPS. Right, sometimes it drops down, but I mean... Right, sometimes it drops down. But also, again, this is on a 10 years old laptop on which I'm also streaming. So it's actually, you know, handicapped really heavily by that. We can try to modify some stuff. Right, so for instance, I can maybe swap around, you know, floor and ceiling colors. Right, so within, you know, within WebAssembly stuff, I can just comment this stuff out. Right, so, and now I can say, this is the ceiling, and this is the floor. This is the floor, and now if I try to compile this entire thing, so that should swap the color of the floor and the ceiling, and thus confirm that they are actually rendered within C3. They're rendered by C. Yeah, okay, so we just proved that it's rendered by C3. So yeah, we ported rendering of the floor and ceiling to WebAssembly using C3. Right. So walls are still rendered in JavaScript, but now we have basically a setup where it's actually pretty straightforward to just move the logic of the renderer from JavaScript to WebAssembly, like very slowly, very incrementally. Looks better with the color swap, maybe. But I mean, it looks different. So no items, no sound. There is sound. It's just very quiet. So here's the sound. And items, I already collected them. So because it retains the state of the game, because it's shared. Right. So because let me actually show you. Right. It's a multiplayer game. So, and I collected the items. So, and that state is retained even if I close one of the tabs, right? So that's why there's no items. So to actually bring the items back, I have to restart the entire server, right? So to refresh this state, and now it is there. So the reason why floor is green is because of keys. So on this floor, it's not particularly convenient, like it's not really visible. I'll have to change the color of the keys if I wanted to make it better, right? So let's actually go ahead and bring it back. So yeah. So is it running? All right, and I can refresh this entire thing, and it's back. So, and what's funny is that I collected only like 2 of them, and if I bring it back, you see, keys are the keys that are not collected are still there, right? Because it maintains the state. Interestingly, I can now do the following thing. Right, I can just that's what I can do. It's a multiplayer game. So it's pretty cool. And eventually we're gonna rewrite all of the parts of the game in C3, except maybe a little bit of the code that is responsible of connecting the client of the game with the capabilities of the browser. But I want to keep the amount of JavaScript as low as possible in this specific case. So at least that's the plan. That's the plan. So, yep, we did it. We actually did it. Isn't that cool? I think that's pretty cool, actually. So, and didn't even take that many changes, honestly. Right, here it is, by the way. So here's the JavaScript version. And I think the time has come to just go ahead and maybe remove the JavaScript version. We don't need it anymore. Bye-bye. It got moved to the C3. Right? So that's what happened. That's what happened. So we just, you know, we reduced like a decent chunk of code. So this entire thing got ported to WebAssembly. So we made some modifications here, and yeah, so in the package.json it's that. Damn, it's really not that much code. It's really not that much code. Just like we just went and we ported it. All right, so I'm gonna commit everything in here. All right, so, and I'm gonna say port render floor and ceiling to C3. via WebAssembly. All right, I'm going to push that right into the repo. So the rest of the stuff that needs to be ported are walls, sprites, and so on and so forth. I will probably do that offline, right? So because I mean it's basically the same process. You just like take the code and move it to C3 module. And if I encounter anything interesting during this process, I might stream that, right? So it just depends because I'm just simulating the process of porting this stuff to C3, and I don't really see anything particularly interesting. If I during porting will encounter something interesting, I may actually do that on the stream, right? So just to share that something interesting with you guys. And once we ported the client, the renderer, we may start porting the logic, right? And that will require simultaneously porting code on the client and the server. Right, so it's going to be rather interesting. So on the server side, we'll need an ability to work with WebSockets. I don't know if C3 has any WebSocket library. We can try to use one of the C++ WebSocket library, or we can try to write our own. Some time ago, I think I tried to implement WebSockets in C. So I had this library. It's kind of unfinished. I just like implemented like a minimal viable like product in this thing, so which is just a client, right? So and it's a C client and it works actually, right? So it actually works. Maybe I can take this code and port it to C3, right, and extend it, right? So because this is basically unfinished client WebSockets, but I can finish it and also implement the server ones and all that in C3. That could be an interesting separate stream by itself. Right, take this old code that I did 3 years ago, by the way, it was 3 years ago, and pour that old code to C3, right, and just like start using it. So that sounds very interesting, actually. So we can try to do that. Right, so let me actually put the this thing in the references for people on YouTube. All right, so that's a pretty cool journey, right? So that's super cool, actually. I'm surprised how easy it is, especially if you know how WebAssembly works. Right, so yeah. So to answer the question, like why you need to understand these low-level things, so then you can take basically an experimental language and just start using it, right? So just start using it, like, because there's no really a proper documentation on how to do these kind of things in this language, because language is experimental, right? So, but if you know how all these things work, like under the hood, how WebAssembly works, you can just pick it up and start using it, right? So that's why, knowing how things work under the hood is important, right? Because you can do these kind of experimental things. You can explore unexplored areas. All right. I guess that's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all on the next recreation programming session with Ahu and Mr. Azozin. I love you all. All right, this is the footnote of the session, and I think I figured out why dynamic memory allocation didn't work in WASM. So LLVM, when it generates for WASM, actually generates a very interesting global value called heap base. Right, so it denotes where in a WebAssembly memory you can actually have a heap. Right, so basically after heap base, you can use this region of memory however you want. And usually what people do, they implement malloc on top of that region of memory. Everything before heap base is either stack or some data, for instance, strings. The thing about C3 is that it actually implements its own memory allocator on top of heap base. And you can find that allocator if you grab specifically for the name heap base. So let's actually go ahead and do that. So I'm going to go into the folder where we store the standard library, and I'm going to literally grab for __ heap base. And I actually did had base, heap base. Right, so there's two places where it's mentioned. The first one is just declaration of that variable, right? So because you need to declare it to be able to refer to it. Right, and then it's initialization of the allocator within a function called initialize wasm mem. Right. So it's a very interesting function. We can't really call it directly because it's private. Right, but if we take a look at the WebAssembly module that is generated when we compile our renderer, right, so here is the WASM module. So let's actually convert that WASM module to what, which is WebAssembly text. So it's going to be renderer WASM, redirect to renderer what, wasn't what. And let's actually find what kind of functions do we export. Actually, not only functions, but different objects and stuff like that. So we export memory, we export a bunch of functions in there that we implemented. So atomic compare exchange, I don't think it's important. There's initialize, right? There's initialize, and as far as I know, it also has a heap base. I think heap base is actually private in this specific case. Okay, so it exports this initialize function. We know it is a function. Let's actually find it within WebAssembly, and it calls to WASM call constructors, right? So let's actually find that. It calls a bunch of other constructors, and most importantly, it calls to initialize WASM mem. So what we need to do, we need to actually call this initialize function before doing anything with WebAssembly. Right, so let's actually go back to dynamically allocating the pixels. So I'm going to go to C3, and let's go ahead and remove all of that, hard-coded screen factor, screen width, and screen height, and make pixels actually dynamic. Right, in the function where we do the allocation, we're going to be actually doing pixels equal mem new array. Yeah, it is new array. So the type we're allocating is a color, and we're allocating width by height pixels. And of course, we need to store the size of the buffer that we just allocated. So we're going to have pixels width. Initially, it's empty, and pixel height, which is initially also empty. So in here afterwards, so we do pixels width, which is going to be actually equal to the width that we received from the caller, and height. Okay, so if we try to compile this entire thing, npm run build, let's see what's going to happen. So there's a bunch of things in here. Yeah, so we are missing screen width and screen height. So it's actually super easy to fix. I'm going to query replace screen width with pixels width. Let's go, and query replace, actually not width, pixels width, pixels width. Jesus Christ, it's hard. Query replace pixels width, pixels width. Let's go. Oh, all right. And the same thing for the height. So let's try to recompile it one more time. Alright, so I think it's going to work this time. It should work this time. Okay, so and if I start serving, alright, so I'm trying to serve the whole thing, and I open the game in here. It's not supposed to work. Let's open DevTools and take a look at the error. Right, memory access out of bounds, which is pretty much expected, right? So now let's actually try to call that initialize function. Right, so it is in a client MTS. Where do we do WebAssembly instantiate? There we go. So this is where we do WebAssembly instantiate. And after we instantiate WebAssembly, what we have to do, we have to take instance, exported functions, and just call to initialize. Right, so TypeScript can't really find this function, right? Because it's not really declared anywhere, because export is just like an abstract sort of like a record thingy, which is just, so it's basically an object with the keys as strings and the values, right? So it doesn't know if it has this function there or not. One way I found to actually make TypeScript shut up about this kind of stuff is just declare it like this as a callable function. But it will be better to have like a very specific interface, right, that just declares all of the exported functions out of the WebAssembly module. And maybe at some point I will do that, right? So the code that is responsible for instantiated WebAssembly in the future is going to be rather small. Maybe at some point we're going to even get rid of TypeScript completely, right? So because I expect the JavaScript code to shrink like significantly, it's going to be just a glue code between browser and WebAssembly module, hopefully at some point. So none of that has to be ready or anything. Okay, so let's actually try to recompile it one more time. Right. And I'm going to restart the game. And the game is working. Look at that. So yeah, we can use dynamic memory allocation in WebAssembly in C3. We just have to initialize everything first, right? So seems to be good, seems to be Gucci. And that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Azozin. I love you.